들리나요?
내말
아, 예, 들려요. 들립니다. 네?
아니요, 저 그 지하 1층에 있는 거 빌려가지고. 가랑 알겠습니다. 네.
개선된 플랫폼에 대해 가지고 우리가 어떻게 그 운영을 할 것인지에 대한 전반적인 데이터를 얻기 위한 것도 있습니다. 그러니까 예전보다는 좀 더 엄성할 수도 있으니까 여러분들이 잘 이해하고 이 플랫폼이 잘 되면 내년에는 좀 더 확장돼서 다른 나라들이 많이 발표를 할 수 있도록 외부 사람들이 발표할 수 있도록 확장을 해볼 생각이니까 여러분들이 해보다가 생기는 문제점에 대해서 피드백을 주시기 바랍니다. 들려?
아, 아. 마이크 테스트. 네, 지금부터 2015년 제3회 인터내셔널 빅오션 메타런스 행사를 시작하겠습니다. 안녕하세요. 빅오션 메타런스의 행사 진행을 맡은 빅데이터 기반 해양융합 전문 인력 양성 사업단 지창도 연구원입니다. 먼저 축사가 있겠습니다. 축사는 제주대학교의 총장님이신 김일환 교수님께서 준비해 주셨습니다. 총장님께서는 단상 앞으로 나와 축사를 진행해 주시면 감사하겠습니다.
반갑습니다. 제주대학교 총장 김일환입니다. 제3회 인터내셔널 빅 오션 메타버스 개최를 진심으로 축하드립니다. 메타버스 공간에서 개최되는 이번 행사는 반갑습니다. 제주대학교 총장 김일환입니다. 제3회 인터내셔널 빅 오션 메타버스 개최를 진심으로 축하드립니다. 메타버스 공간에서 개최되는 이번 행사는 제주대학교 4단계 BK21 빅데이터 기반 해양융합 전문인력 양성 사업단 주최로 열리며 올해로 벌써 세 번째를 맞이하게 되었습니다. 해양 빅데이터 연구 결과를 공유하고 심도 있는 토론을 위해 메타버스 공간에 함께해 주신 미국, 호주, 인도, 스웨덴, 아랍에미레이트의 박사 및 연구자분들, BK21 교육연구단 교수님들과 대학원생 여러분께도 깊은 감사의 말씀을 전합니다. 빅데이터 기반 해양융합 전문인력 양성 사업단은 해양과 빅데이터의 융합으로 4차 산업혁명 시대의 새로운 학문 분야를 개척하고 있습니다. 오늘 개최되는 메타런스에서는 메타버스 공간을 통해 연구 결과를 발표하고 공유하게 됩니다. 이 가상의 공간은 활발한 소통의 장으로 거듭날 것이며 제주대학교의 혁신적인 시도로 기억될 것입니다. 특히 올해의 빅 오션 메타런스는 지난해보다 더욱 발전된 기술을 바탕으로 편의성과 현실성이 대폭 향상된 것으로 알고 있습니다. 이런 발전을 토대로 제주의 해양 빅데이터 및 메타버스 산업 부흥에 기여하고 4차 산업혁명 관련 학문을 발전시키는 값진 시간이 되기를 기원합니다. 끝으로 오늘 빅 오션 메타런스 준비에 수고를 아끼지 않으신 배진호 BK11 교육연구단장님을 비롯한 사업단 관계자 여러분께 깊은 감사의 말씀을 드리며 참석하신 모든 분들의 무한한 영광과 발전을 기원합니다. 감사합니다.
네, 축사를 준비해 주신 총장님께 감사의 인사드립니다. 다음으로 저희 빅데이터 기반 해양융합 전문 인력 양성 사업단의 단장님이신 배진호 교수님께서 개회사 및 개회 선언문을 읽어주시겠습니다. 단장님께서는 단상 앞으로 나와 낭독해 주시면 감사하겠습니다.
감사합니다. 제가 개사를 우선 낭독을 하고 그 다음에 간단하게 이 플랫폼의 취지에 대해서 그리고 앞으로 우리가 나아갈 방향에 대해서 말씀을 드리겠습니다. 우선 낭독을 하겠습니다. From now on, I announce the opening of the third international big ocean metarence. This third metarence is upgraded several functions, especially it can support a local limited area set of audio communication, and we can join all you in the platform through server and avatar optimization. For this reason, I am sure that the metarence will be a cornerstone of opening the metaverse space into the new force space in our lives. Now we are going to move forward one step at a time to create a new meta space. I would like to thank everyone who attended this international metarence. 우선은 개회 선언을 했고요. 지금 여러분들은 새로운 경험을 지금 하고 있습니다. 어떤 경험이냐면 여러분들에게 저희 교육연구단이 보여주고 싶은 것은 이런 것입니다. 여러분들은 지금 현재 우리가 과학과 기술 이런 것들을 할 때 그 과학 기술자들은 꿈을 꾸는 사람들입니다. 그리고 그 꿈을 이루려고 노력을 하는 사람들입니다. 뭐 봄, 여름, 가을, 겨울의 노래 가사처럼. 그리고 그 꿈을 이루고 이룬 꿈을 다른 사람들에게 퍼뜨려서 그 꿈을 공유하고 같이 행복해지는 사람들이 과학자이자 기술자들입니다. 이거는 제가 생각하는 생각입니다. 근데 지금 현재 우리가 살아가고 있는 이 공간보다 더 다른 공간이 있을 거라고 생각이 되었습니다. 그래서 몇 년 전서부터 시작된 공간은 메타버스 공간입니다. 그래서 여러분들에게 이러한 메타버스 공간에서 여러분들의 꿈을 하나씩 이루어 여러분들이 원하는 꿈을 다른 사람들에게 공유를 할 수 있는 이러한 공간들을 소개해 드리고 싶은 마음이 저희 교육연구단에서 있었던 것입니다. 그래서 이러한 것들을 위해서 여러분들에게 제공하는 이 플랫폼은 저희들 교육연구단이 굉장히 열심히 지창도 연구원, 그 다음에 고상호 연구원이 되게 열심히 개발을 하였고, 그래서 지금 현재 음성도 이 플랫폼 안에서 들어가고, 그 다음에 영상도 이 플랫폼에서 영상이 플레이가 될 수 있도록 개발이 되었고요. 그 다음에 캐릭터 옵티마이제이션이든 전반적인 영상 옵티마이제이션을 통해 가지고 여러분들이 쉽게 액세스를 할 수 있도록 플랫폼을 개발하게 된 것입니다. 앞으로도 계속 플랫폼을 업그레이드를 할 것이고, 그리고 여러분들에게 새로운 경험을 제공시켜 드릴 것입니다. 여러분들 마음대로 꿈을 꾸시고 마음대로 그 꿈을 현실화할 수 있도록, 그리고 여러분들이 마음대로 여러분들의 꿈을 공유할 수 있도록 그렇게 저희들 열심히 도움을 드리도록 하겠습니다. 그러면 여러분들 이 플랫폼에서 마음껏 노시기 바랍니다. 감사합니다.
네, 축사를 준비해 주신 저희 단장님께도 감사의 인사를 전해드립니다. 저희 지금부터 7분간 휴식 후에 45분부터 다시 우수한 논문 성과를 보인 참여대학원생 발표를 시작하도록 하겠습니다. 7분 휴식 후에 10시 45분부터 동일하게 자리에 착석해 계시면 됩니다. 다음으로 2024년 한 해 가장 우수한 논문 성과를 보인 참여대학원생인 지구해양융합학부 해양시스템공학 전공의 노만 무하마드의 특별 발표가 있겠습니다. 이 학생에 대한 소개는 배진호 단장님께서 직접 해주시겠습니다.
안녕하세요. 요번에 올해로 저희들이 새롭게 하나를 만들었습니다. 프로그램을. 그 프로그램은 뭐냐면은 여러분들 인센티브를 부여를 할 때 여러분들께 어워드를 주는 형태로 했고요. 그거는 이제 논문하고 특허, 해외 논문하고 특허, 그 다음에 국내 논문까지 해가지고 전반적으로 평가를 해서 여러분들한테 평가를 하였고요. 그 중에 가장 우수한 논문 성과를 보인 학생이 있었습니다. 그 학생이 노만 무하마드고요. 노만 무하마드는 2024년 우수한 논문 성과를 보였는데요. 실적은 SCI급 논문 총 13편을 게재하였습니다. 이 중에 주저자 논문, First Author 논문은 8편입니다. 그리고 이 논문들의 임팩트 팩터 최고는 32점이고요. 다른 논문들 중에 임팩트 팩터 점수도 뭐 19, 17, 16 등 우수한 성과를 보였습니다. 그리고 이 학생이 얻은 결과 중에는 대학원에서 주최했던 24년 하반기 교육연구단 BK Honor Award for Student에서 최우수상을 받았고요. 그 다음에 우리 교육연구단 자체 우수 참여대학원생 논문 실적 1등을 해서 이번 메타런스의 특별 발표 세션에 발표를 부탁하게 되었습니다. 자, 그러면 이제 여러분들도 매년 여러분들도 조금만 더 노력을 하셔서 이 학생처럼 인센티브도 좀 많이 받으시고 그 다음에 상도 받으시고 그 다음에 메인 스테이지에서 발표를 해주시기 바랍니다. 자, 그러면 please start. 노만.
Hello everyone. My name is Noman Muhammad and I am a PhD student under the supervision of Professor Jinhobe, and my research topic is triboelectric and electrochemical energy devices based on advanced hybrid nanomaterials. So if we talk about mechanical energy harvesting, particularly the triboelectric nanogenerators, and the challenges that we are facing in this field are the low output performance and the stability issues. So to overcome these issues, the material science is there. So if we use the material science, we can synthesize different kind of materials, like we can do chemical modifications, nanomaterials and composites, hybrid systems, and surface morphological modifications. So based on these modifications, the triboelectric materials that are being synthesized, they can be used as a tribopositive material or tribonegative material. So if we characterize these materials based on the tribopositivity and tribonegativity, the triboelectric series is there, which the materials who accept the electrons easily, they are called tribonegative, and the materials that can donate the electrons, they are known as tribopositive materials. So based on these ideas, we tried to synthesize materials who can be very high power output, and they can be stable in worse environmental conditions. The electrochemical energy storage, the other part of my research area, and particularly focusing on supercapacitors, and the challenges that we are facing in this field are, if we want to make a perfect supercapacitor or energy storage material, we should have improved electronic conductivity and strength and structure stability and effective active surface areas for oxidation induction potential. So various kind of surface and material processing and material synthesis treatments are being done to improve these qualities and to achieve these properties. So some of them are heterogeneous engineering, morphological engineering, defect engineering. So through these strategies, we can develop various kind of materials like traditional materials, emerging new materials, and some advanced materials. So our goal is to develop hybrid materials to achieve pseudo capacitance and high electrochemical double layer capacitance, high energy and power density with excellent cycling stability. So if we start our the research on triboelectric energy harvesting and what kind of hybrid materials that are being used in this, the first work that I will present is the triboelectric energy generator for green energy harvesting using coastal bio-waste Ulva Lactuca from Jeju Island. This paper was published in Journal of Science Advanced Materials and Devices, and we collected the Ulva lactuca from the seashore of Jeju Island, and then we processed, and then we did some cleaning treatments and ball milling treatments to make fine powder of the Ulva lactuca, and then we use this Ulva lactuca powder for in triboelectric energy harvesting devices to produce the electricity, and then we use these devices to light up LEDs and stopwatch. The device mechanism is this: that pressing, releasing, released, and pressing the electron discharge transfer through electrostatic induction and electrostatic electrostriction, and then charge is induced outside of the structure. So this is that device mechanism that Ulva we used as a tribopositive layer, and this tribopositive layer was used, and then when in contact with the tribonegative layer, the charge is produced. So this is the SEM characterization and thickness of the film that we made on the tank device, and this is the EDX characterization and FTIR analysis. This is the tank performance analysis and electrical characterization. This is the representation, the schematic representation of the device, and current voltage output performance, and the power output, and then current voltage performance at different frequencies, and then current voltage output performance with respect to the different area of the device, and then polarity switching test of the device. So then we compared the device performance with some tribopositive layers like cellulose powder, aluminium, PET, PTFE, and then we use this device to charge some capacitors, and then these capacitors were charged and discharged during this through this device. Then the energy stored in each of these capacitors and stability, short-term stability, long-term stability, and then the device performance under different humidity conditions, and then this device was used as a humidity sensor. Then we use this device for real-time applications. We use this device to run the LEDs and then stopwatch, and then biomechanical energy harvesting, and the other work that we did, this is the controlling triboelectric charge of MOFs by leveraging ligands chemistry. So by keeping the problems in mind, environmental stability, high power output, how binary, single binary and ternary ligands influence triboelectric charge in MOFs, and how the different kind of ligands like type 2 methylimidazole, benzene tricarboxylic acid, and BDC. We used these three ligands, and then we used in combination of these materials like 2 and at the end we combined all of these three ligands, and we synthesized 7 cobalt cerium based MOFs then to investigate that how the chemistry of ligands is affecting the tribopositivity of the MOFs. So this is that molecular, orbital, and electrical configuration of 2-methylimidazole, BDC, and BTC ligands, that we can see that in 2-methylimidazole we have electron donating orbitals, and in case of BDC we have some electron donating and electron withdrawing molecular orbitals. So as a result, the synergistic effect of these combination of 2-methylimidazole with BTC, we can get some high charge donation and electrons available to be donated to the tribonegative material during the contact and separation process. And then the XRD analysis was performed, and FTIR analysis shows the presence of functional groups that were responsible for charge donation, and UV spectroscopy shows that these molecules were successfully formed, and the bathochromic shift were observed, which shows that the materials are successfully formed. Then the morphological and surface structure of the particles were observed through the SEM analysis of all the samples. And then the TEM analysis was also performed, which shows the presence of nanorod-like structure in the best performing MOFs sample, which shows that these kind of areas act as a charge generation and charge transfer spots. The charge. Then electrical characterization and its application, they were performed, and we can see that the high output was obtained for cobalt cerium BTC, and current and voltage, they showed maximum performance. Here also different ligands combination is showing that maximum performance was shown to thirimethazole BTC when it was used in 1:1. This is the stability performance of the device, and this is the output power performance of the device, and this shows how the different capacitors, commercial capacitors of a different capacity, they were charged, and it's charging discharging of the capacitor, and this shows how these devices were able to run the LEDs and commercial calculator. The second work that is related to the embedding of iron carbide inside the porous organic network for superior tribocharge performance. Nanoparticles, how they influence these properties, and the pyrazine sites of 2D.
약간 시스템이 오동작을 하는 것 같아요. 그래가지고 지금 다시 수정을 하고 있습니다. 안 돌아가. 지금 갑자기 시스템이 튕겨가지고 우리 서버 쪽 시스템이 튕겨가지고 약간 오동작이 일어났습니다. 지금 이쪽은 동작을 하고 싱크가 안 맞는, 다 싱크가 안 맞아. 지금 이 현상은 클라우드 쪽에 액세스를 할 수 있도록 독립적으로 서버로 동작하는 느낌을 지금 받고 있습니다. 그래가지고 이 부분에 대해서 어떻게 전부 다 아마 지금 노만 학생이 이야기하는 내용과 넘기는 내용과 각각 다 들릴 거거든요. 지금 여기에서 중계 쪽에서 세 개의 컴퓨터를 동시에 지금 키고서 하는데 프레젠테이션 넘기는 것이 다 따로따로 지금 돌아가고 있습니다. 그래서 지금 이 부분에 대해서 잠깐 수정을 하고 다시 발표하는 걸로 하고 5분 동안 휴식을 하겠습니다. 튕겨서 나가면서 서버랑 각각의 그 보는 청자 그러니까 보는 시청자들과의 그 파워포인트가 넘기는 싱크가 잘 안 맞게 되어버렸어요. 그렇게 해가지고 그 부분을 지금 서버 셧다운을 하고 다시 했는데 나중에 다음에는 이런 현상에 관련돼서 정확하게 파악을 해가지고 이 플랫폼을 개선하도록 노력하겠습니다. Talk again. I am sorry.
I will resume my presentation from this point. So the next work that I'm going to present is that how the iron carbide embedded pyrazine based porous organic networks for superior tribocharge performance. So in this material we face the problems that how the iron carbide nanoparticles then be anchored or integrated on inside of the bone structure, that how and the pyrazine ring, which consists of nitrogen doped elements, can be act as a site where these particles can be attached. So then we investigated the tribocharge output performance, and this is the schematic representation of the development of iron carbide based carbon nitrogen bone porous organic network. This is the physiochemical and morphological characterization and the XRD analysis, which shows the successful formation of the bone structure. Then the DF's density TGA analysis, the thermal investigation shows the thermal stability of these materials, and the charge particles on the surface of the materials were investigated by zeta potential. And FTIR analysis shows the presence of the functional groups, and then wettability of the materials were investigated through contact angle measurements, and this is the SEM analysis. Then to investigate the successful formation of these materials, the high resolution transmission electron microscopy was performed, which shows the distribution of iron carbide nanoparticles inside the bone structure, and this is the latest fringes that are present inside of the high resolution time images, and which is in good agreement with the XRD analysis, and which shows the same planar peaks in the XRD analysis. And this way we shows that how the material has been synthesized successfully, and this is the ADX analysis, which shows the presence of carbon, nitrogen, and iron. Then the working mechanism and tribocharge performance of these bone-based tank was performed, which shows that the integration resulted in enhanced 10 times enhanced current and voltage performance, and the current and voltage at different frequencies. And then this is the output performance, and this is the polarity switching test, and then the cycling stability performance up to 10,000 cycles. That device shows that it's stable performance. The second part of the presentation is advanced hybrid nanomaterials for electrochemical energy storage devices, particularly focusing on supercapacitors. So the first work in this area I would present, and this is the design and synthesis of Pani integrated cobalt carbonate hydroxide hydrate based nanocomposites for high performance supercapacitor. So in this process, in this work, we face the problem that the sea urchin shaped nanocomposites can be developed through solvothermal process, and they show the sluggish kinetics which reduce their performance. But we used the addition of Pani, which resulted in enhanced specific capacitance, and sluggish kinetics of CCH were overcome, and we got energy and high energy and power density. Then we use the theoretical calculations like Dunn's model for charge storage mechanism. This is the schematic representation of the synthesis of the material, and this is the schematic representation which shows how the electrode samples were prepared, and the further 3 electrode sample was performed. This is the TEM analysis, which shows that sea urchin shaped particles morphology was obtained. This is the TEM analysis, which shows the sea urchin shaped TEM particles morphology, which is good for the charge storage performance. And this is this material shows the Pani particles how are distributed inside the material, and how these materials were 4 compositions were performed without the addition of Pani, then 10 milligram addition, 20 milligram, and 30 milligram addition of Pani. We got the maximum results, optimized results for 20 milligram addition of Pani. This is the XRD analysis and FTIR analysis, which shows the successful formation and presence of the functional groups. This is the Raman shift, which shows the presence of carbon shift, carbon peaks, and this is the BET analysis, which shows that how the porous structure we got, which is beneficial for electrochemical energy storage. So then we did the electrochemical characterization, in which we used the 3 electrode assembly, and then we performed the cyclic voltammetry at different scan rates. Then the comparison, which shows that the maximum integrated area under the curve was obtained when the 20 milligram addition of pani was carried out. And this is the GCD analysis at different applied current densities, and then the comparison of GCD curves, and the maximum charging discharging curve was obtained when the 20 milligram addition of polyaniline was added. This is a specific capacitance versus current graph, which shows the maximum result for the 20 milligram addition of pani. And this is the EIS analysis, and then the charge and discharge capacitive and diffusive contribution were studied through the R square values of the current density versus scan rate graph. And then the thermodynamic visibility of the materials was studied through potential difference versus scan rate graph. Then the maximum result obtained were 20 milligram addition of pani. We used this material as a positive electrode, and as a negative electrode we used the porous carbon, which acted as a ADLC electrode. And then we made an asymmetric supercapacitor device, in which we first optimized the potential window of the device, and then we got the positive potential window and negative potential window CV curves of the 2 electrodes. Then we check the device at different scan rates and GCD at different applied currents, and charging discharging continuous charging at applied current of 7.5 millivolt, and then specific capacitance and stability performance and EIS analysis. After during the specific during the stability performance, we perform the EIS analysis and then Bode plot, and then the comparison with the literature, and then the energy density and power density graph, which shows the device best performance. The second work in electrochemical energy storage devices, it is the magazine-based 2D, 3D heterostructure development for enhanced supercapacitive performance. So this paper was published in Chemical Engineering Journal. We use, because in magazine we face the problem of stacking and agglomeration, and we propose a 2-step process in which we can overcome these two problems. And magazine enhanced 2D, 3D heterostructure was developed, and then asymmetric supercapacitor device was performed. This figure shows the schematic representation and the chemical reactions that were involved, and the 2-step process that shows the successful formation of the 2D, 3D titanium carbide, titanium oxide, copper titanate heterostructure. And the copper titanate particles were successfully attached on the surface and inside of the magazine. The physiochemical and morphological characterization shows that the material was successfully developed through XRD analysis, and these 2D, 3D heterostructures shows that the spacing between the atomic layers of the magazine, they widened, and that is good for the incorporation of the charges. And this is the SEM analysis of the 3 samples, and this is the TEM analysis, which shows the successful formation and the presence of lattice fringes of all the respective planes which are being labeled in the XRD analysis, and XPS analysis, which shows the presence of all the carbon, oxygen, titanium, and copper deconvoluted peaks inside the structure, and the presence of the corresponding bonds and functional groups that were responsible for the electrochemical energy storage. Then electrochemical energy characterization was performed using a 3-electrode assembly, in which CV, GCD, EIS analysis was performed, and then the comparison of these 3 characterization techniques, which shows the best results were obtained for when we attach the copper titanate, which is also a dielectric material, and which act as a charge electroactive sites were increased through the incorporation of copper titanate, which resulted the enhanced performance. Then asymmetric supercapacitor was made, and then the performance we optimized the potential window of the device through GCD at different potential window and CV at different potential windows, and then the device performance was investigated, GCD, CVD, CV, GCD, and EIS analysis. And this is the circuit of the EIS analysis. Then Dunn's model was performed to investigate the charge and capacitive and diffusive contribution, and then the stability, performance, and then the Ragon plot and the comparison with the previously reported literature. The third work in this area is the incorporation of iron carbide based porous organic networks for superior and electrochemical double layer capacitance. So we see that when we added the iron carbide, we see the enhancement and widened potential window. This is the potential window from 0 to 0.6, and this is the potential window from minus 0.6 to plus 0.6. Similar. And this is the comparison of the CV analysis, and we compare the CV analysis at different electrolytes like alkaline electrolyte, which is potassium hydroxide, and the ionic liquid. And ionic liquid shows further widening of the potential window. Similarly, the widening of the potential window was also observed in GCD analysis, which shows the widening of the potential window from this comparison potassium hydroxide. And when we use the ionic liquid, the further widening of the ion potential window was observed. The maximum results were obtained in the ionic liquid, and the presence of iron carbide nanoparticles resulted in enhanced capacitive performance, which is also confirmed by low conductivity of this material through EIS and body plot. Then the DFT calculations and charge transfer mechanism was studied through DFT calculation, theoretical calculation, which is a DFT, and which shows that the first how the potential window was widened, and how the charge transfer was eased in the triboelectric charge transfer, and how the electrochemical double layer capacitance was improved. First, the optimized structures were obtained through DFT calculations. Then the potential density of state graph were obtained, which shows the presence of carbon iron peaks inside the iron carbide bone, and the electron density graph, which also shows the presence of hot spots, and how the electrons are able to denote and transfer inside the structure when we added the iron carbide. So if I conclude my presentation, the two aspects of the presentation, the first part of the presentation is the triboelectric energy harvesting, and we successfully synthesized the tank device from the bio waste, and then we used this bio waste to run the device and LEDs. Then MOF based tank device, and then the porous organic network based tank device we successfully developed. And the other side, we developed the nano composite, which is based on copper CCH and Pani nano composite, and then we did work on the magazine, and then finally we did the work on the iron carbide based bone structure. Thank you very much, and if you have any questions, you can ask.
Okay. Have any questions?
질문 있으신 분들은 숫자 1키 눌러서 마이크 키신 후에 질문해 주시면 됩니다.
여러분들이 생각하는 동안 제가 하나 질문을 하겠습니다. Norman?
Yep.
Can you hear?
Yes, Professor.
Okay. I have one question. Why you are you starting the nano generator, energy harvesting, and then energy storage both? Why do you start these different two topics?
Uh, Professor, I think although these are different two topics, but in future my goal is to combine these two topics like integration, like for self-powered devices. If we combine the triboelectric nanogenerator with the supercapacitor devices, and particularly if we talk about the micro supercapacitor devices, so in this way we can use the triboelectric nanogenerators to charge the micro supercapacitor device, and then we can use the micro super this setup, this complete assembly as a self-powered system. So that's why, although there are different fields, but in future we have this thing that we will combine and we integrate these two fields.
Okay. Is the combines? You talked is the combining meaning. Is the combining meaning is the what? Is the I think is the in your future is the do you want to one device for both the energy harvesting and then energy storage?
Yes, Professor, that's exactly our goal, that we will make one device which can simultaneously get the energy from the environment and then also can store the energy.
Okay, thank you. Have any question, guys? It is the also the is the platform is the not complete. So I think is the you please the you will participate is the we can easily improve our platform. Please ask. And then Sheka or Jungmin and then Saurabh. Please ask. 서울업이 없나? 서울업 있네. 서울업.
Hello.
Okay. As the please ask for the is the Dr. Normal.
Hello. Hello, Dr. Norman, can you hear me?
Yes, I can hear you.
Okay, I have one question. So, the material part, the which type of properties, enhanced performance of, for supercapacitor also and tank?
Yes, if I show you my first slide. In this slide, you can see that how the output performance of the tank device can be improved through a material science aspect. So if we have basically the electron donation properties of the material, they are the key role. And if we can increase these properties, that it means that we can generate a good tank device. For this, we can have some chemical modifications, nanomaterials and composites, hybrid systems. So these are techniques and some other surface morphological and surface treatment techniques that are also beneficial to enhance the electron donation properties of the tank. And if you talk about the electrochemical energy storage, so we want to have some oxidation and reduction, which is the key aspect in electrochemical energy storage. So we can, if we increase the oxidation and reduction potential of the material, so in this way we can increase the energy storage performance of the material.
Okay, thank you.
Okay, thank you.
Have any question, guys? Okay, is the I have is the final question is the for Norman.
Yeah.
Is the you like this is the for the device? Which one is the important? Is the for the materials and then synthesis, and then is the process, and then is the measurement. Among these, is the you think is the which one is the important for to take these researches?
Professor, I think these 3 or 4 parameters that you mentioned, they are interlinked with each other. So if we do some literature review, and then based on this literature review we make some material, then we characterize this material, that whether this material is good for this specific application or not. So based on these things, then we use this material as an application. So I think these three or four things, they are interlinked with each other. So based on these things, we can finalize that this material and this application is good, or it can be further investigated or not.
Okay. Do you have any more question? Okay. Don't have any questions. This presentation folder is normal. Please be kind.
So thank you for this.
네, 더 이상 질문 없으신 걸로 알고 이번 1분 세션 마치도록 하겠습니다. 잠시 후 12시부터 식사 배부가 준비되어 있는데 지금 도시락 배달 현황 파악해가지고 지구해양 학생들은 본인들 과 사무실에서 받아가시면 되고요. 내 말 들리지? 받아가시면 되고, 해양시스템공학 전공 학생들은 지하 5067 호실에서 받아가시면 됩니다. 12시 맞춰서 오시면 될 것 같습니다.
도시락 뭔지 설명해.
아, 네. 도시락은 저희 히치마부시 장어덮밥으로 준비했으니까
굉장히 노력했더니.
시간 맞춰서 하나씩 받아가시길 바랍니다.
이번 도시락은 조금 단가가 있습니다. 여러분들 를 위해 나름 최대한 노력을 했고요. 되게 많이 고심을 해서 선택을 했는데 맛있을지는 모르겠습니다. 지금 현재 뭐 굉장히 많이 장어도 비싸지고 그랬지만 장어덮밥 되게 뭐 괜찮을 것 같아서 계속 간혹 회, 초밥이라든가 아니면은 뭐 버거류 이런 걸로 했었는데 이번에는 조금 여러분들 한테 좀 다른 색다른 도시락을 좀 소개시켜 드리고 싶어 가지고 준비를 했고요. 한번 드셔보시고 여러분들이 한번 피드백을 주시기 바랍니다. 맛이 어떻는지, 그리고 어느 정도 괜찮은지, 그렇게 해가지고 저희들 행사 때 도시락의 다양성을 좀 이해할 수 있도록 이런 것들도 피드백을 주시면 감사하겠습니다. 그리고 점심 식사 맛있게 하시고 그런 다음에 1시부터 저희들 다시 시작을 할 거고요. 1시부터는 발표자들이 많으니까 댄스하게, 그러니까 좀 밀도 있게 저희들 시작을 해서 차근차근 해보도록 하겠습니다. 지금 현재 이 플랫폼에서 노만이 곧 2월 달에 졸업을 하니까 닥터 노만이라고 부를게요. 닥터 노만이 발표를 했고, 발표를 한 다음에 약간의 이제 서버하고 동기화가 잘 안 맞는 문제가 생겼습니다. 그리고 질문과 답변에서 이런 부분들은 꽤 괜찮게 지금 스무스하게 동작을 했던 것 같아요. 그리고 여러분들이 이러한 부분들을 들었을 때 좀 뭐 괜찮게 들었는지, 그리고 현장감은 못 느끼겠지만 현장에서 있었던 느낌과 비슷한 건지, 그러한 부분들에 대해서도 여러분들 피드백 주시기 바랍니다. 그러면은 점심 끝나고 오후 세션 때 뵙기 바랍니다.
들리시나요?
네, 들립니다. 한 소절로 한번 바꿔주시죠. 지금
네, 맞습니다.
네, 안녕하십니까. 2부 행사 자장을 맡은 빅데이터 기반 해양융합 전문 인력 양성 사업단 지창도 연구원입니다. 2부는 저희 사업단 참여 대학원생들의 진행 연구에 대해서 구두 발표가 있겠습니다. 첫 번째 발표자이신 지구해양융합학부 해양시스템공학 전공의 김정민 학생의 구두 발표가 있겠습니다. 발표자는 숫자 1키를 눌러 마이크를 켜신 후 발표 위치로 나와 발표 진행해 주시면 됩니다.
헬로.
네, 잘 들린다.
네.
잠시
여기는 다 들어가 있는
네, 들립니다. 네.
네, 다시 시작해 주시면 됩니다.
네. Hello. My name is 정민. Today I'm gonna be discuss about Internet of Things system with active touch switch based on coffee bean triboelectric nanogenerator. So nowadays energy resource is a very hot issue for the depletion. So many researchers and scientists have to study about the sustainable energy technology development. So one of the solution is to make a tank triboelectric nanogenerator. So especially for using the tank is a recyclable material also nowadays a trend. So in this study we using the green coffee bean for the tank device. So green coffee bean called a CGB, as we make a tank material as a green coffee bean, and we characterization of the uh, device for the tank, and and we also make a application, IoT application. So this is the green coffee bean images. So in this, based on in this figure, we can utilize green coffee bean as a tank device. So when using the tribal tank device, so we press and process of the press and release, they can occur the voltage. So this left figure is the voltage of the green coffee bean as a tank, and right figure shows us the stability. So during the 30 minutes, so green coffee bean based tank is a very good material, and stability is also good as a tank device. So furthermore, we make a IoT application. Name is the switch array application. First, we make a green coffee bean tank array like this, and connect the Arduino for the gain the voltage value. So in here, Arduino is used. So every time voltage is occurred, Arduino calculate about the which index tank device or max voltage. After that, they transmit the Arduino ESP and checking the LED. In LED is show the some number which is the tank device maximum voltage in tank device index. So furthermore, not as well as furthermore, not the LED, and also we using the speakers. So like similar situation, instead of the LED, we can occur the sound signal like a pitch came in the baseball. So 들리시나요?
네, 잘 들립니다.
네. So LED and speaker application as a IoT application we can utilize. So conclusion is we find the green coffee bean green coffee bean as an eco-friendly bio material, so we can utilize it as a tank device and can make energy harvesting system, and also with the integration with the IoT system, make a switch array, so we can utilize IoT application with this device. So thank you very much. Any other question?
네, 감사합니다. 질문 있으신 분들 숫자 1키 눌러서 마이크 키시고 질문해 주시면 감사하겠습니다.
발표는 여기서 마치겠고요. 혹시 질문 있으시면은 바로 받겠습니다.
질의응답 없으신가요? 질의응답 없으신 걸로 알고 두 번째 발표 진행할게요. 방금 발표해주신 발표자분은 숫자 0키 눌러서 마이크 꺼주신 후 자리로 돌아가시면 감사하겠습니다. 두 번째 발표는 지구해양 융합학부 지구해양과학 전공의 강소영 학생의 구도 발표가 있겠습니다. 발표자는 숫자 1키를 눌러 마이크를 켜신 후 발표 위치로 나와 발표 진행 바랍니다. 강소영 학생 준비되셨나요?
네, 준비됐습니다. 근데
네.
제 캐릭터는 지금 앉아 있는 상태고 캐릭터를 다른 학생 캐릭터로 해서 발표를 진행하도록
네네네,
하겠습니다.
알겠습니다. 그 발표 끝나기 전까지 발표 창 끄지 말아주세요. 그렇게 되면
네.
PPT가 좀 꼬이는 상황이라서. 준비되는 대로 바로 발표 시작해 주시면 돼요. 지금 마이크 꺼진 거 같거든요. 네, 이제 다시 켜진 것 같아요.
네, 발표 시작하겠습니다. Hello, I'm Soyoung Kang. I will today talk about the modeling the underlying drivers of spatio-temporal evolution of CO2 uptake in the plume discharge from the Changjiang River. First, the ECS, where is one of the river-dominated marginal seas in the northwestern Pacific. A large amount of fresh water discharged from the Changjiang River. Many studies have suggested.
잠시만요. 지금 혹시 페이지 모델 셋업 페이지 맞으신가요? 발표창 껐다가 다시 키셨죠?
아, 네. 그치. 지금 인프로? 아, 이거 제가 보는 거랑 창이 다르다. 어?
형 넣고 마이크 안 들려. 넣고 마이크 안 들려. 너 마이크 안 들려. 0번 눌렀다 1번 다시.
저 이거 제가 누르는 거랑 옆에 화면이랑 다른데 어떡하죠?
네, 그것 때문에 싱크 안 맞는 것 때문에 끄지 말라는 거였는데 잠시만요.
네.
이전 버튼 끝까지 한번 눌러보시겠어요? 그 발표창 끝 켜져 있는 거에서 끝 한 번 더. 네, 지금 표지 보이시죠?
아니요, 콩쿨러졌는데
한
맨
번-
마지막.
한 번 더 눌러.
전혀 아닌 것 같아.
끝 페이지 한번 맞춰보시면.
끝 페이지요?
네. 지금
알지. 어떡하죠?
잠시만요.
제가 그 다른 화면 보고 발표할까요?
네네, 그렇게 하시는 게 나을 것 같아요. 잠시만요. 그럼 표지 페이지를 맞춘 다음에 시작을 할게요.
네.
PPT 한 장씩 넘기셨을 때 제가 표지 나오면 말씀을 드릴게요.
뒤로
지금
가면
표지
될 것
아닌가요?
같아요.
지금 표지 아니에요. 3번 뜨거든요.
지금
3.2.
저희
유튜브 송출로 유튜브 송출 맞춰줘야 돼.
아 진짜?
유튜브 딜레이 있어가지고
아 네.
지금 컴퓨터 2개로 보고 계시나요?
3개요.
3개요? 지금
아.
그러면은 발표자로 띄우던 사람 거랑 나머지 2분께 싱크 안 맞으시죠?
맞습니다.
그렇죠. 그러면은 그 나머지 2분 싱크에 맞춰주실래요?
두 명은 지금 표지.
네, 나머지 2분이 표지고 유튜브는 3번인데
나머지
유튜브로 맞추는 건가요?
잠시만요. 나머지 2분이 지금 표지예요?
네.
백 버튼 눌러서 꼬인 것 같은데 그러면은
잠시
이거를 지금 보이는 화면을 그 표지로 맞추고 거기서 지금 이전 버튼 눌러서 표지로 맞춘 다음에
근데 지금 여기 3세대인데 3세대 이런 사람이
다시 기록한 거.
너무 많이 발생하니까 실감 상황 네, 다시 발표 시작하도록 하겠습니다. 강소영
네,
학생 준비.
시작하겠습니다.
네.
네. Hello, I'm Soyoung Kang. Today I'll talk about that modeling the underlying drivers of spatio-temporal evolution of CO2 uptake in the plume discharged from the Changjiang River. First, the ECS where is one of the river-dominated marginal seas in the northwestern Pacific. A large amount of freshwater discharged from the Changjiang River. Many studies have suggested that the surface partial pressure CO2 in river plume is mainly affected by biological processes such as high primary production leading to low CO2. However, it still remains challenging to accurately quantify the role of physical and biological processes in modulating carbon cycle in time and space because of limited temporal and spatial in situ measurements. Therefore, in this study, we use high-resolution 3D-dimensional coupled model, physical, biological, and carbonate model to investigate the carbonate system dynamics of the shear plume spreading over the ECS. Then we identify the main drivers of spatio-temporal evolution of CO2 uptake within the CRP in 2060, when a large amount of freshwater discharge than climatological freshwater discharge. We use RAMS. This is the model domain. We use eco-monthly climatology data for initial and boundary conditions. 6-hourly surface forcing was used for 2016, where year study from CFS data. Importantly, we use daily river discharge data from the Changjiang. Our ocean circulation model is coupled with the biological model based on a fish type model. The carbonated system model is also coupled to calculation model to investigate the carbon cycle within the river plume. First, we investigate the spatio-temporal evolution of CO2 uptake within the CRP during summer in 2016. This figure shows the horizontal distribution of CO2 and CO2 flux. The dotted line indicates SSS lower than the CRP. As you can see, the surface CO2 within the CRP has a distinct spatial evolution from shore estuary to offshore. High CO2 in estuary decreased sharply toward the near shore, showing lowest in the near shore list. Therefore, the shore estuary strongly decreased CO2 to atmosphere, while the near shore list act as a significant CO2 sink from the atmosphere. As the CO2 increased from the near shore to offshore list, CO2 flux transitioned again from a strong CO2 sink for atmosphere to weak source. Then next we are going to find the main drivers rolling CO2 within the CRP. To identify the main drivers controlling evolution of oceanic CO2 uptake, we designed 3 experiments as below. Experiment 1 is control condition containing all processes such as physical, biological processes, and air-sea CO2 exchange. Second, same experiment 1 except air-sea exchange. Lastly, experiment 3 contains only physical process. As you can see, the comparative experiment indicates this effect. These are the comparative experiment results. This figure shows the meridionally averaged CO2 and CO2 flux within the CRP for each experiment. In EXP 1 and 2, CO2 show sharply varying from the highest in the inner estuary to the lowest in the nearshore list, and then gradually increasing towards the offshore list. Meanwhile, in EXP3, PCOT is very higher than other two experiments and have little spatial change from nearshore to offshore. Nearshore list in EXP1 and 2 acts the strong sink by lowered PCOT. Importantly, EXP2 maintains strong sink to weak sink from nearshore to offshore, where EXP1 switched from strong sink to weak source in the offshore. This result suggests that the main drivers enhancing CO2 uptake is biological process, and air-sea exchange process also play an important role in determining CO2 uptake variation in offshore. So to find how biological process reduce PCOT in the offshore list, we check the biological process for this section. So these figures are time longitude graph. As you can see, this nutrient limitation condition, supply of high concentration of PO4 from the Changjang River discharge promote biological activity under the P limitation condition. Chlorophyll concentration reflecting biological activity are increased in the nearshore list and sharply decreased from nearshore to offshore with decreasing PO4. The strongest drawdown of PCOT appear in the nearshore list biological DIC consumption. Consequently, the high PO4 concentration from the Changjiang discharge play an important role in promoting chlorophyll blooming in the nearshore list. Chlorophyll blooming in the nearshore list strongly reduces PCOT by consuming DIC. However, chlorophyll blooming does not occur in the estuary despite the high concentration of PO4. Therefore, to identify
네, 잠시만요. 지금 잠깐 흰 페이지 나서 이전 페이지 한 번만 눌러주시면.
네?
그 발표 자료 이전 페이지. 네. 지금 4 이펙트 맞죠? 바이올로지.
네, 이건 맞는데.
그 다음 페이지. 하시고
지금은 보이는 것 같아요.
지금 보이고 하나 더 남겨보시겠어요? 네, 됐어요. 지금 보이시죠?
네.
네네.
진행하겠습니다.
네.
We investigate the role of particle mix by comparing without tidal effect in estuary at this point. This is time depth graph tide on and without tidal effect. In tidal on case, low chlorophyll concentration occurs total water column. In tidal off case, high chlorophyll concentration occurs upper layer. Strong particle mixing due to tides inhibits biological production in the estuary despite being supplied with a high concentration of nutrients from the Changjiang. Turbidity by particle mixing also restricts the biological activity by lower incoming solar radiation. As a result, chlorophyll blooming appeared in the nearshore list with weakened particle mixing. I am going to summarize them. The simulated PCOT exhibit distinct spatial temporal variation within the CRP, decreasing sharply from estuary to nearshore. The CRP transition from a source in estuary to a strong sink in the nearshore list and to a weak oceanic CO2 source in the offshore. Chlorophyll blooming in the nearshore makes strong CO2 sink and air-sea exchange make offshore act a weak source. But strong particle mix due to tides inhibit biological production in estuary despite high concentration PO4 input. In the nearshore list, the biological activity becomes stronger by weakened particle mixing, resulting in enhanced oceanic CO2 uptake. As a result, biological process play the most important role in enhancing oceanic CO2 uptake, and air-sea exchange and tidal mixing also contribute to determining spatial evolution of CO2 uptake. Thank you.
네, 감사합니다. 질문 있으신 분들은 숫자 1키 눌러서 마이크 키신 후에 질문해 주시면 감사하겠습니다. 질문 없으신가요? 일단 강소영 학생 끄지 마시고 그 다음 고은하 학생 바로니까 고은하 학생 페이지 누르시면 되거든요. 위에서.
네, 알겠습니다.
한번 클릭 한 번만 해주시겠어요?
잠시만요.
네. 아니 지금 고은하
네, 안녕하세요. 혹시
학생.
들리시나요?
네, 잘 들립니다.
네,
지금
지금
표지에
첫 페이
맞으시죠?
네, 지금 첫 페이지입니다.
네, 알겠습니다. 잠시만요.
네.
그 다음 세 번째 발표로 지구해양 융합학부 지구해양과학전공의 고은하 학생의 구두 발표가 있겠습니다. 준비되시는 대로 발표 바로 진행해 주시면 됩니다.
네, 알겠습니다. 그럼 발표 시작하겠습니다.
네.
Hello, thank you for attentioning my presentation. I'm Unako and I'm going to be presentation on the subject of effect of real-time land cover change in the intertidal zone on meteorological and ozone prediction in coastal areas. My presentation today will consist on four parts: introduction, meteorology and method, result and discussion, and summary and conclusion. Coastal region undergo continual change in coastal line and land cover type due to the dynamic interaction between the ocean and land, including erosion and sediment disposition driven by the oceanic physical processes such as wave and tide, as well as human activities. Alteration in coastal land cover can result in change in land surface parameter in adjacent areas, consequently impacting their local meteorological conditions. Their local meteorological conditions directly and indirectly affect the diffusion, accumulation, and transport of ozone concentration in and around this area. Despite the significant of high resolution the land cover and land use in meteorological and air quality simulation of the intertidal zone, in most period studies and the land cover configuration in meteorological model remains fixed throughout the simulation. This practice has contributed to uncertainties and limitations in meteorological and air quality prediction within and around the intertidal zone, hampering our understanding of the complex physical products and their feedback mechanism between the intertidal zone and the atmosphere. Therefore, to enhance meteorological and air quality prediction for coastal areas, the real-time land cover change in the intertidal zone were applied to the three-dimensional meteorological model, and the meteorological fields that incorporated time-varying land cover due to tide were used input to the air quality model. For this study, our focus was centered on the intertidal zone of Gyeonggi Bay, which represents the largest intertidal zone along the western coast of South Korea. The study period was selected to be the 3 days before and after the 15th day of the lunar day, when the tidal influence is greatest. The study period was selected to be 3 lunar day, when the tidal influence is greatest and high ozone concentrate occurring in the last 10 years. The WRF version 3.8 meteorological model was employed to assess the impact of time-varying land cover due to tide in the intertidal zone on coastal meteorological change, and we used air quality model CMAQ version 502 was employed to assess the impact of change in meteorological in the intertidal zone due to tide on coastal ozone concentration. The detailed description of the WRF and CMAQ model used in simulation is shown in the table. The tidal simulation consisted of the model run with time-bound land cover, and control simulation consisted of run with fixed land cover. The LAMS ocean model was used to calculate the hourly spatial change in the model grid corresponding to the area of the intertidal zone. To obtain more accurate intertidal area for assessing meteorological and ocean impact, the intertidal zone derived from the coupled model was adjusted using multiplicational image from the Landsat 8 OLI satellite image. When applying the finally calculated intertidal area to geogrid in the WRF model, the landmass on the grid corresponding to the intertidal zone were modified from ocean and land, and the land use from water body to herbaceous land. Using this modified geogrid, the WRF model was conducted continuously at 1 hour intervals. Overall, the comparison of the intertidal zone applied to the WRF model with the satellite-based intertidal zone showed moderately good spatial homogeneity during high and low tide. The international zone at the low tide in the WRF model was similar to the satellite image. Therefore, we determined the time-varying intertidal zone simulated in this study is well simulated. From the WRF simulation using the adjusted intertidal area, the change in land use categories owing to intertidal land cover variation substantially affected the change in land surface parameter. In the tidal simulation, following the land use change from water body to herbaceous wetland, the mean albedo and surface roughening length values in the intertidal zone were significantly higher than contour simulation. Conversely, soil moisture values were significantly lower than contour simulation. These alternation in land surface parameter in the tidal simulation are affected to influence meteorological conditions and ozone concentration. We compared tide and contour simulation and observations to assess the effect of time-varying land cover in the intertidal zone on the accuracy of meteorological variables and ozone concentration. In general, temporal variation showed closer agreement with the observation at most sites in the tidal simulation compared to the contour simulation. Notably, change in the most meteorological variables and ozone concentration were more pronounced in the intertidal area during low tide than during high tide. This difference can be primarily attributed to the substantial alteration in land surface parameter during low tide as opposed to high tide, owing to significant land cover change in the intertidal zone. To examine the spatial impact of time-varying land cover on ozone concentration, the difference in meteorological variables were compared for daytime and nighttime at low tide during the study period. First, the daytime. The ozone concentration in the tidal simulation increased by an average of 11.82 ppb in the intertidal areas and increased by an average of 6.45 ppb in the inland area. The change in ozone concentration were more pronounced in the intertidal zone, where land cover changed indirectly. The ozone concentration in the intertidal zone during daytime could be attributed to elevated photochemical production due to the increase in the air temperature. In the inland, the increased ozone concentration could be attributed to the elevated sea breeze from the intertidal zone transported ozone concentration to the inland areas. Also, the accumulation of ozone concentration in the inland area was likely due to the decrease in wind speed. Second, the nighttime. The ozone concentration in the tidal simulation increased by an average of 4.98 ppb in the intertidal areas and increased by an average of 5.57 ppb in the inland area. Given the absence of photochemical production of ozone concentration at night, the increase in the nighttime at low tide ozone concentration is likely due to the persistence of elevated daytime ozone concentration into the night. Additionally, the decrease in wind speed in the intertidal zone likely contributed to some acclimation and increase in ozone concentration. Integrate process rate analysis were performed to analyze the relative contribution of physical and chemical process to ozone concentration change. In the intertidal zone of the tide experiment, chemical and vertical process which are mainly influenced by increasing the air temperature change reactive rate contributes significantly to ozone production. Inland ozone concentration increased significantly with proximity to the intertidal zone, with horizontal advection contributing a large positive contribution. This suggests that stronger rear intertidal area sea breeze transportation ozone concentration from its tidal zone to inland. In this study, we conduct a quantitative analysis to assess the influence of time-bound land cover within the intertidal zone on coastal meteorological variables and ozone concentration. This result revelated that temporal change in the intertidal zone had a significant impact on ozone concentration in both the intertidal and surrounding area. Notably, this impact and contribution of time-bound wind cover within the intertidal zone to change in meteorological variables were significantly greater at the intertidal zone compared to inland during the low tide. Therefore, this study is significant as a quantitative assessment of the impact of real-time land cover change in the intertidal zone on coastal ozone concentration. That's all I have prepared for you today. Thank you for your time.
네, 감사합니다. 질문 있으신 분들은 숫자 1키를 눌러서 마이크를 켜신 후 질문해 주시면 감사하겠습니다. 질문 없으신가요? 네, 그러면 질문 없으신 걸로 알고 발표자분은 자리로 이동해 주세요.
이거 혹시 백 눌러도 되나요?
네, 지금 아예 끄셔도 됩니다. 그 다음 김진순 학생, 네 번째 발표는 지구해양융합학부 지구해양과학 전공의 김진승 학생의 구두 발표가 있겠습니다. 발표자는 숫자 1키를 눌러 마이크를 켜신 후 마이크 테스트 먼저 진행해 주세요. 김진승 학생, 마이크 테스트 해주세요. 김진승 학생 연결되는 대로 발표 진행할 거니까 잠시만 기다려 주시기 바랍니다.
아, 들리시나요?
네, 잘 들립니다. 단상 나와서 발표자로 켜주세요. 렉 많이 걸리시면은 발표자로 키실 때 바닥 보고 키시면 되거든요. 2키. 네, 지금 표지 키신 거 맞죠? 마이크 안 들리고 있어요. 혹시 장지현 학생 자리 있나요? 장지현 학생 계시면은 장지현 학생 먼저 진행할게요. 네, 들리는데 목소리가 좀 많이 작게 들리거든요. 한번 말씀해 주시겠어요?
지금 들리시나요?
네, 들리는데 방금 페이지 나가져서 아마 꼬였을 거거든요. 그래도 한번 진행해 보시겠어요? 발표자를
네,
한번
잠시만요.
들어볼게요.
지금 표지 켰거든요.
아니요, 지금 인트로덕션으로 돼 있어요. 지금 표지예요.
지금 표지예요.
네, 지금 인트로덕션이고. 저희 건 맞는데
그 표지로 맞춰놔서 한 번만 더 이전 한 번 더 눌러주세요. 한 번 더 눌러주세요.
한 번 더.
네, 그러고 나갔다가 백 버튼 눌러 나갔다가 다시
지금
한번
여기 화면에는 그 맨 마지막 장 나오는데
그러면
나가나요?
넥스트 버튼으로 표지 한번 지금 맞춰주시면
네, 지금 여기 표지입니다.
돼요. 그럼 나갔다가 백 버튼으로 나갔다가 다시 한번 해주시겠어요? 네.
이거 보면서 발표할 이걸 안 쓰는데 맞춰서
지금 표지 보이긴 하거든요. 지금 인터럭션.
여기 표지가 두 장이 되어 있는데요.
지금 지금 인트로덕션인가요?
아니요, 지금도 표지이긴 해요.
표지예요?
넥스트. 네,
그러면 이전 버튼 한 번 누르고 나갔다가 다시
여기서 나갔다.
네. 지금 다시 한번.
그리고
지금 표지로 시작하셨죠?
아니면은 여기서 지금 이전 버튼 두 번 눌러서 한 번 더 누르셔서 한 번
두
더
번
누르고 네, 한 번 더 누르고 네, 여기서 나갔다 다시 들어오면 될 것 같아요.
지금 표지화면 맞으시죠?
표지가 두 장이 된 것 같아요.
네. 지금은 어떠세요? 지금 표지 맞아요?
아니, 지금 넥스트 눌러서 인트로덕션인데 지금 화면에는
네.
표지가
안
나오는.
맞고 있어서 잠시만요. 장지현 학생 마이크 연결됐나요?
아, 그러면 그 옆에 그 창 띄워놓고 그 다른 화면 보고 발표해도 될까요?
네.
네.
네, 그렇게 맞춰서 해주세요. 지금 유튜브 화면이랑 제가 보는 화면이랑 똑같으니까 그거 맞춰서
네.
해주시면 될 것 같아요. 지금 표지입니다. 지금.
네, 지금 인트로.
네,
네,
맞아요.
알겠습니다. 발표 시작해 주세요.
그럼 발표 시작하겠습니다.
네.
Hello, my name is Jin-Seung Kim. I study in Atmospheric Science Lab. I'm here to present our study title, Effects of Direct Aerosol Feedback on Meteorology and Particulate Matter in South Korea using the WRF-CMAC two-way coupled model. In general, aerosols are solid particle and liquid drumlet that are produced from a variety of sources like anthropogenic and nature and are suspended in the atmosphere. There are two main type of main aerosol sources. First, anthropogenic source such as industrial emission and vehicle exhaust. A second, nature source such as sea salt and desert dust. Aerosol can alter weather and climate by interacting with radiation and cloud and can combine with air pollutant to adversely affect air quality and health. Aerosol have two major feedback effects. First, the aerosol direct effect, where aerosol absorb and scatter solar radiation, reducing the sunlight reaching the surface. Second, the aerosol indirect effect, where aerosol act as cloud condensation and modified cloud property, such as number of cloud drumlet size and residence time of cloud. In this study, we focus on the direct feedback effect on meteorology and particulate matter concentration. Most previous studies on aerosol direct effect in Korea has analyzed overall aerosol feed effect using a single East Asian domain, and study analyzing aerosol direct effect at high resolution are still lacking. Korea is located downwind of large-scale emission source in China, resulting in frequent high PM2.5 episode due to the effect of highly concentrated pollutants transported over long distance. So we performed a high-resolution WPCMAC two-way coupled model simulation accounting for aerosol direct effect to analyze high PM 2.5 cases during February to March in 2019. Our objective is to examine the high resolution aerosol direct effect on meteorology and their influence on PM 2.5 concentrations using advanced modeling techniques. We conducted this study using the WPCMAC two-way coupled model at high resolution during February 17 and March 15 of 2019, targeting period of high PM 2.5 concentration. We made 3 domains for analysis high resolution aerosol feedback effect in South Korea. The figure shows the model domain in this study. Domain 1 is East Asia at 27 km resolution and including the Gobi Desert. Domain 2 is East Asia and Korean Peninsula at 9 km and including Beijing. Domain 3 is South Korea at 3 km. We analyzed the aerosol direct feedback effect about domain 3. We use NSEP GDAS FNL to 0.25 degree reanalysis data as the meteorological model input data. We use anthropogenic emission EDGAR version 6.1 for domain 1 and 2, domain 1 and domain 2, and CAPS 2019 data for domain 3. We use natural emission data, MEGAN version 2.1 for all domains. We collected the observations data at 70 meteorological monitoring sites and air quality monitoring sites for solar radiation, air temperature, wind speed, related humidity, and particulate matter concentrations. This table shows the WPCMAC two-way coupled model, grid and physics options. WPCMAC two-way coupled model used plane CU land surface model, ACM2 PBR scheme, plane CU surface layer. We set the calling ratio of WPCMAC to 5:1 based on previous study. Including aerosol direct effect in the simulation, referred to as YF, improve the accuracy of all meteorological variables such as solar radiation, air temperature, wind speed, and relative humidity, as well as particulate matter, including PM10 and PM2.5, compared to simulation excluding aerosol direct effect referred to as NF. This was confirmed through IOA and the RMSE and showed a level similar to that of previous studies, and the degree of model improvement was also comparable. We found the solar radiation and wind speed and relative humidity were overestimated, while air temperature and PM10 and PM2.5 were underestimated. The aerosol direct effect reduced solar radiation called RAD over the domain. We found that high particulate matter areas exhibited a significant reduced the RAD. This attributed to the scattering and absorbing of solar radiation caused by particulate matter. The reduction pattern of air temperature and planetary boundary layer height, called PBLH, over the land are similar to the decrease in RAD. Difference in temperature and PBLH between land and ocean are attributed to factors like thermal inertia and atmospheric heating by long-wave radiation. Wind speed and related humidity exhibit difference between land and ocean, likely influenced by stability change from temperature and PBLH for wind speed, and by saturation vapor pressure change from temperature for related humidity. Aerosol direct effect increased the average PM concentration over the land, with higher concentration in northern South Korea and lower concentration in South, likely due to decreased PBLH and wind speed and increased related humidity in northern region. The increase in secondary organic aerosol called SIA in the northern region contributes to rise in PM2.5 concentrate, with nitrate showing a spatial distribution similar to PM2.5 and likely playing the largest role in the decrease of PM2.5 concentration in the southern region. The spatial distribution of nitric acid, a precursor of nitrate, showed a decrease in southern region, suggesting that reductions in nitric acid and nitrate concentration contribute to decrease in PM2.5 level in the area. This study used a high resolution of CMAC two-way coupled model to analyze aerosol direct feedback during the high PM event, showing improved simulation accuracy with result closer to observations. RAD decreased across the domain, reducing air temperature, PBH, and wind speed over the land while increasing related humidity with PM concentration, generally increased but decreasing in southern region due to reduced nitrate and nitric acid and relative small change in meteorological factor in south. And the limitation is the interaction between meteorology and aerosol complicated identifying the exact cause of PM reduction, emphasizing the need for further high resolution of CMAC model studies. Thank you for your attention.
네, 감사합니다. 질문 있으신 분들은 숫자 1키 눌러서 마이크 켜신 후 질문해 주시면 감사하겠습니다. 질문 없으신가요? 없으신 걸로 알고 발표자분은 숫자 0키 눌러서 마이크 꺼주시고 자리로 돌아가 주시면 감사하겠습니다. 다음으로 장지연 학생 마이크 테스트 먼저 진행하겠습니다. 장지연 학생 한 번 더 말씀해 주시겠어요? 좀 끊기거든요.
들리세요?
들리는데 끊겨요.
들리는데 끊겨.
계속 끊기거든요. 앞으로 나오셔서 그 다른 캐릭터들 최대한 안 쳐다보고 있어 주실래요? 렉 걸리셔서 마이크 끊기는 것 같거든요. 단상 와서 단상 2키 누르지 마시고 바닥 보고 한번 말씀해 주세요. 네, 발표자로 키지 마시고 말씀 한번 해주세요. 마이크 테스트 먼저 진행할게요.
들리세요?
계속 얘기해 주실래요? 여보세요?
네.
끊기는 건지 뭔지 파악이 안 돼서 계속 좀 마이크 테스트 좀 몇 번 해주세요.
그냥 다른 마이크랑
네, 마이크 변경하고 키세요. 지금 발표자를 아직 키지 마시고.
여기에서 너무 시간이
들리시나요?
네, 좀 더 테스트 해주세요.
네.
지금도 끊겨요. 컴퓨터 렉이 걸리시는 건가요? 아니면 어떤 상황이죠? 말씀 한번 해보실래요?
들리시나요?
네, 들려요. 말씀하실 때만 마이크 켜지는 것 같거든요. 지금 마이크 연결이 어떻게 되는 거죠? 이어폰으로 진행하고 계시나요? 네. 마이크 재연결 하시는 대로 계속 테스트 해주세요. 계속 듣고 있으니까 저는.
들리시나요?
네, 들려요. 계속 말씀해 주세요. 여보세요. 잠시 15분 동안 휴식 시간 갖고.
들리시나요?
네, 지금 들려요. 계속 말씀해 주세요.
내가 안 들리는 거 같지? 아무 소리도 안 들려.
네, 여보세요. 여보세요. 제 목소리 안 들리시는 거면 마이크랑 스피커 연결 잘못된 거가 맞거든요. 바탕화면 설정 가셔서 마이크 입력 설정이랑 스피커 출력 설정 다시 보셔야 돼요. 잠시 15분간 휴식 시간 갖고 2시 30분부터 다시 시작하겠습니다. 장지현 학생부터 다시 시작하겠습니다. 한 다음에 마이크 먼저 다시 해요. 발표자로 키지 마시고 마이크 먼저 확인해주세요. 아,
네네, 들립니다. 아, 네, 알겠습니다. 아, 네. 네, 잠시만요. 들리세요? 아니요, 재접속했어요. 마이크가 안 되면. 아, 네, 알겠습니다. 지금 아까 컷했나? 여기
한번 꼬여가지고 그 아예 그냥 백 버튼 누르셔도 되니까 백 버튼 눌렀다가 다시 한 번 더 다음 버튼 누르시고 표지 나올 때까지 들어가요. 지금 여기 있는 표지 부분이거든요. 혹시
네네.
다른 거 보면서 보여주실 수 있어요?
아, 네네. 그렇게 하겠습니다. 발표 시작할게요. 네.
네, 지금 발표 시작해 주세요.
네, 알겠습니다. Hello everyone, my name is 지연 Jang. Today I will be presenting on the topic stratification, phenomenon, and phytoplankton community changes on Jeju coastal waters in 2022 and 2023. First, let me briefly introduce the table of contents for today's presentation. Phytoplankton are the most important.
지금 마이크 목소리가 안 들리는데 들리세요? 하다가 끊겨가지고 지금 마이크가 안 들리는데 혹시 들리시나요? 아, 들리시나요? 쉐카? 쉐카.
Hello. Hello. Hello.
Hello?
Hello.
쉐카? Are you 쉐카?
Yes. Yes, sir.
Okay. If you're ready, you can start now.
Yes. Yes, sir. I am ready.
Press E button.
셀카 이름 눌렀고 그다음에 넥스트랑 프리비어스 버튼 보이거든. 아직 안 눌렀어. 바로 시작하면 돼. Now you start.
Hello. Good afternoon, everyone. I am Chandrasekhar Sambhaji Patil, and today I am going to present my work entitled Synergetic Integration of Graphene Quantum Dots into Metal Organic Framework for Enhancing Triboelectric Nanogenerator Performance. These are my contents that I cover today in my presentation. Like first one is introduction, second one is experimental section, third one is resultant discussion, and lastly we discuss about the conclusion that in my work. As we know that energy is the lifeblood of modern civilization. However, yet we find to ourselves at a crossroads where our growing demand threatens to outpace the planet's ability and sustain it, which making energy is the most pressing crisis current situation. As we know that there are two types of energy sources like non-renewable and renewable. In non-renewable energy sources like energy sources limited resources covers the natural gases, coals, nuclear, oil, and in renewable energy sources it cover the wind, solar, biomass, geothermal, and water. However, apart from the non-renewable and renewable energy, currently or until today, everyone is used only the non-renewable energy sources, but no one used the renewable sources. Only less amount of energy sources we used to date, as you see in this figure, or here you can see the world map. Only less amount of renewable energy sources are used to cover or to fulfill the demand of energy crisis. That's why world are getting wide pressing of energy crisis. However, renewable energy sources are the permanent solution to cover our world's energy crisis. Renewable energy is generated from the natural resources such as sunlight, wind, rain, tides, and geothermal heat, which are renewable. Also, the waste to energy is the new kind of renewable energy sources that we can utilize to fulfill our energy demand. In this, we can use the new kind of technology, that is triboelectric and piezoelectric nanogenerator. However, in this work, we use the triboelectric nanogenerator to fulfill our energy demand by converting the waste renewable mechanical energy into the electricity from triboelectric effect. Triboelectric nanogenerator can convert various forms of renewable mechanical energy such as vibrations, humans, and wind into electricity, paving a self-powered electronics for sustainable energy solutions. Triboelectric nanocell also a sustainable power generation source, high output voltage performance of source, also easily convert mechanical energy into the electricity, and it has a diverse a wide range of application. Triboelectric nanometer are working on basically on two principles or two phenomena like triboelectric effect and electrostatic induction. In triboelectric effect, when two materials come into physical contact and then separated, one material tends to the gain electron while the other loses electron, leading the generation of opposite charge and electricity. However, in electrostatic induction, the separation of triboelectric charges creates a potential difference, including flow of electrons and an external circuit to balance the charge when connected. As we see in this figure, this is the triboelectric effect. Like firstly, contacted the materials, and then in electron transfer are generated, and the charge generation will occur. There are four types of working mode in triboelectric nanometer. First, as you see in figure, like contact separation mode, lateral sliding mode, freestanding layer mode, and single electrode mode. Although the triboelectric nanogenerator is cover our energy demand, also it had some challenges. Like inadequate charge stability, insufficient material advancements, a limited surface charge density, high charge recomposition rate, and low electron mobility. To cover these challenges, there are also opportunity by like a layered structure. We can design the tank with multiple layers. We can develop novel materials, and also we design nanostructuring architectures, integration with another technology and IoT and sensors. By keeping this opportunity in our work, we can utilize the material perspective, and we develop the new kind of material that is graphene quantum dot incorporated MOF composite. Why we select the MOF composite? Because MOF has already strong properties like integration of potential, high porosity, high electron transfer capability, and dielectric properties. To increase to fulfill our energy demand, we can incorporate the graphene quantum dots, because graphene quantum dots has high chemical functionality, high surface area, high charge density, and excellent electric conductivity. This property will boost the MOF properties, and we can achieve the desired voltage or desired electricity to fulfill our energy demand. These are the experimental section. In this experimental, we can use the zinc nitrate hexahydrate and DMF, and we can make this MOF by co-precipitation method, and similarly we can also make the composite by adding the graphene quantum dots in similar way. And these are the physiochemical characterization. The first figure showing the FSM analysis, like surface morphology of our developed composite. As we can see in figure first, there is no any rough or no any porous nature. While in the second figure, the SPCM image of MOF composite, we can found the porous morphology of our material, which will help to boost the charge transfer rate by quantum confinement effect. Secondly, we can find the XRD, FTR, BET, UV analysis, and Raman analysis also. This will also show the potential of our composite material, which will help to charge transfer generation. These are the fabrication and mechanism of our tank devices. In figure in first half, we can see the device structure, how we made our device. We can use PET as a substrate and copper as a charge collector layer, and copper and aluminum used as a charge collector layer, while PTFE used as a tribo-negative layer and MOP used as a tribo-positive layer. Why we use the graphene quantum dots as a tribo-positive layer? Here we can see our in the Zeta potential, we can analyze our the surface charge of on our composite is positive. That's why we use the tribo-positive layer. In second figure, we can see the contact separation mechanism of our tank devices. Which follow the 4 steps like contacted, separating, fully separated, and again pressing. This cycle was continuously generated and which will generate energy. These are the electrical measurements as we see in figure A and B. It clearly indicates that our composite material show better performance as compared to the bare MOP, which indicates the graphene quantum dots incorporation enhance the electrical charge transfer or electricity, which will help to cover our energy demand. Simultaneously, we can perform we can check the experimental parameters like effect of different tribo-negative layers such as cellulose, lignin, PET, and PTFE. Also, we can check the impact of frequency on our devices by varying the frequency from 2 Hz, 4 Hz, 2 and 5 Hz. From results, we can see that according to the frequency, our device show different performances, which indicates our device are show or generate electricity by low frequency also. In the next slide, in a further experiment, we can check the power of our devices. In first figure A and B, we can see in figure A show the power of the bare MOP composite, bare MOP tank device, and figure B show the power of the composite based tank devices. From figure we can see that the composite based tank device high power as compared to the bare MOP tank devices, which covers energy demand. Further, we can check the impact of humidity and temperature on our tank devices. From results, we can see that there is no any impact on our tank devices because it's gets hydrophobic nature. That's why it shows stable performance over the environmental harsh conditions like temperature and humidity. At last, we check the stability, long-term stability of our tank devices, which is more important during real-time applications. And we can check the cyclic performance or output performance over 30,000 cycles, and it shows the stable performance over long-term stability, which might or which will very helpful when we use our devices in real-time applications. At last, we can check our device usability in real-time applications by running calculator and glowing LED. As we see in figure A and B, our devices show better performance. It will glow the 300 LEDs. Even its size is very low by 2 cross 2. Also, we can check one good application to measure or to test the speed of vehicles, and these are the results. In figure A, we can use from low weight to high weight vehicles, and we can find or we can take the vehicle speed using our tank devices. in conclusion, this paper has mainly this focus on development of novel material for high potential use in energy harvesting. Also, as a cornerstone in advancing sustainable energy, leveraging the unique properties of MOP, we can enhance the performance of tank device by incorporation of graphene quantum dots. Furthermore, the proposed tank has effective to powering commercial capacitors and potential applications in biomedical energy harvesting, physiochemical motion monitoring, and vehicle speed recognition. This also capable to highlight the device versatility and utility across various technologies and scientific domains. At last, this research contributes meaningfully to the evolving field of sustainable energy technology by demonstrating the scalability and reliability of high-performance tank devices. And this work we has published in the Advanced Composite and Hybrid Materials, having impact factor 23, which is good journal. And thank you.
네, 감사합니다. 질문 있으신 분들은 숫자 1번 눌러서 마이크를 켜신 후에 질문해 주시면 감사하겠습니다.
Thank you, sir.
Have any question? Okay, thank you, 셰카.
Okay, thank you, sir. Thank you.
지구해양 융합학부 해양시스템공학 전공의 파틸, 찬드라, 셰카르, 산바지 학생의 구두 발표가 있었습니다. 다음 발표로 지구해양 융합학부 해양시스템공학 전공의 나타라잔 센틸 쿠마르 학생의 발표가 있겠습니다. 발표자는 숫자 1번 키를 눌러서 마이크를 켜신 후에 발표 위치로 나와 발표 진행 부탁드리겠습니다. 센틸.
Hello, can you hear me?
Okay.
Hello.
Hello.
Yeah, can you hear me?
Yeah, I can hear.
Okay.
I can hear you.
Okay.
Okay. If you're ready, please start the presentation.
Okay. Okay. Good afternoon, everyone. I am Sendil Kumar. My topic is optimization of power takeoff for a wave energy converter positioned near a vertical seawall. To mitigate the climate change impacts, moving to renewable energy is crucial because the energy sector is the largest contributor of greenhouse gas emissions. Wave energy is a clean and renewable energy with higher power density compared to solar and wind energy. So it has a great potential to meet the world's energy demand. However, it lacks commercial viability due to a high levelized cost of energy compared to other sources. So to improve its commercial viability, wave energy converters can be installed near shore and integrated with the existing onshore structures. So this approach has several advantages like cost sharing, relatively easy access for installation, operation and maintenance compared to offshore installation, and a direct onshore grid connectivity. Wave energy converters rely on PTO system to transform the wave energy into a usable form like electricity or other types of energy. So by optimizing the PTO, we can maximize the energy conversion efficiency. So the PTO system can connect the WEG to the onshore structure using a frame and hinge mechanism. Also, if the onshore structure to which the PTO system is integrated with the WEG is reflective, then wave power extraction can be enhanced because of standing waves. So this study is focusing on optimizing a PTO system for a wake placed near a vertical seawall in irregular waves. The diagram shows the wake placed near a vertical seawall. The PTO system is connected via frames and hinges. One end is connected to the wake and the other end is integrated into the vertical seawall. For the optimization, a few parametric variations are considered. I considered different diameters of wake, 2 meter, 3 meter and 4 meter. Then the lengths of the different segments of the PTO system are varied, which include hinge position of the PTO system frame and the length of the actuating arm. Then the real PTO damping is varied. When wave energy converter is in motion, the movement of the frames either stretches or compresses the PTO system. So to calculate the equivalent forces exerted on the PTO system, a mathematical formulation based on the movement of the frame is derived. Since wake is in heave motion, only the vertical forces is required. So the vertical force is a function of a geometric formulation of different lengths of the PTO system frames. With this, we can derive the equivalent PTO damping coefficient and the real PTO damping coefficient required to achieve the equivalent damping. When the wake oscillates near a vertical seawall, the interaction must be accounted. So the present study applies a method of image to account for the vertical seawall. So in this method, the vertical seawall can be replaced by an image body symmetrically placed on the opposite side of the seawall in addition to the actual wake with the bidirectional incident waves. So the hydrodynamic parameters of the actual floater can be obtained by combining the hydrodynamic parameter of the actual floater with the hydrodynamic parameter of the image floater due to the forced oscillation of the actual floater. So the plus or minus depends on the motion direction in the mirror. The wake is oscillating only in the heave motion. So the equation of heave motion is expressed as the summation of the inertial term, damping term and stiffness terms. The heave motion response obtained from this equation can be used to calculate the time averaged power extracted in regular waves, which also can be extended to irregular waves. I am using Janswap spectrum for irregular waves. Conventionally, we can obtain the optimal PTO damping by taking a derivative of extracted power, which leads to a frequency dependent optimal PTO damping. Practically, we can take a single value. So the optimal PTO damping at the natural frequency is considered the best option. So therefore, the real PTO damping can be obtained as a function of geometric formulation and the optimal PTO damping at the natural frequency. Let me share the results. These plots are showing the real PTO damping required to achieve the equivalent optimal PTO damping at the natural frequency against the variation in the hinge position of the PTO system frame and the lengths of the actuating arm for each diameter of wake. The result shows that the real PTO damping is higher when the hinge position is closer to the fixed end. It gradually decreases as the hinge moves away from the wall, reaching a minimum value at the midpoint of the actuating arm, and then starts to increase as the hinge position approaches the free end connected to the wake. The variation in actuating arm length significantly affects the real PTO damping. This variation is narrow for smaller diameter wake, while it is higher for large diameter wake. These variations can be attributed to the hydrodynamic interactions between the vertical seawall and the wake, influenced by changes in the wake's placement within these interactions. So based on the results, the hinge position at the midpoint of the actuating arm yields the lowest real PTO damping. With its optimal hinge position, the extracted power is calculated across different arm lengths. So from the results, it is observed that the wake closer to the vertical seawall achieves higher power extraction. When the wake is away from the wall, the power reduces. This reduction is higher for the larger diameter wake because the wake placement is dictated by its diameter. So they are placed farther. Based on the analysis, the optimal PTO conditions are listed in the table. For all diameters, the hinge position at the midpoint of the arm and arm length closer to the wall are the optimal positions. So the corresponding PTO damping and power are given in the table. Power extraction increases with the diameter. So in conclusion, PTO system frames positioning the wake closer to the seawall while maintaining the hinge position at the midpoint achieves higher power extractions with optimal PTO diameter. This outcome is primarily influenced by the hydrodynamic interaction between the wake and the seawall. The extracted power increases with the wake diameter because larger wakes with their greater surface area and ability to accommodate larger PTO systems enhances the energy capture by effectively trapping the waves and interacting with the incoming wave energy. Thank you.
네, 감사합니다. 질문이 있으신 분들은 숫자 1키를 눌러 마이크를 켜신 후에 질문해 주시면 감사하겠습니다. Have any question? 질문 없으신가요? Okay, thank you for your presentation.
Okay, thank you.
네, 다음 발표로는 지구해양융합학부 해양시스템 공학 전공의 이기배 학생의 구두 발표가 있겠습니다. 발표 전에 마이크 테스트 먼저 진행하도록 하겠습니다.
네, 들리시나요?
네, 잘 들립니다.
네.
준비되시면 발표 위치로 나와서 바로 시작해 주시면 됩니다.
네, 바로 시작하겠습니다. I start my presentation. Good afternoon, I am Kiberi, a PhD student in the Department of Ocean System Engineering. Today, I will be presenting on the topic Generation and Evaluation of Underwater Out of Distribution Sonar Signals using Generalized Virtual Ultra Synthesis. The neural networks have demonstrated impressive performance across various application fields. However, this performance relies on the assumption that the evaluation data possesses statistical characteristics similar to those of the training data. In real-world environment, models may receive out-of-distribution (OOD) data that significantly deviates from the round statistical characteristics, leading to misclassification and reduced reliability. In actual passive sonar system, as shown in the presented figure, all the signals can occur in cases such as differences between detection and training environments or varying maneuverability stage of the same vessel during training and detection. To address these issues, virtual ultra synthesis VUS generates all the data in the feature space by assuming a class conditional multivariate Gaussian distribution. However, applying this assumption is challenging for passive sonar signals due to the environmental variations and the diversity of sound sources. In this study, we propose generalized virtual ultra synthesis GVOS, which approximates the feature space of sonar signals using a class conditional multivariate Gaussian mixture model to generate out-of-distribution data. GVOS employs the expectation and maximization algorithm to estimate the statistical parameters of the class conditional multivariate GMM in the feature space. Subsequently, virtual ultra synthesis are generated by sampling from regions of the estimated Gaussian mixture distribution with low probability. While VUS assumes that in distribution multivariate GMM, GVUS estimates the probability density function of ID data using the EM algorithm. The related mathematical expressions are shown on the right section. The following figure compares the virtual outliers generation by GVS and VUS based on ID features. As seen in the left figures, when the ID has a characteristic of a single Gaussian distribution, Both VUS and GVS generate virtual outliers in the low probability regions of the ID distribution. However, when the ID distribution exhibits characteristics of a Gaussian mixture distribution, GVS demonstrates superior outlier generation compared to VUS. Finally, we compare the outlier generation performance of the proposed GVUS with VUS using CBR data. CBR data consists of recorded ship engine sound from actual ports. In this study, engine noises from passenger ship, ro-ro ships, and cruise ships were processed using short-time Fourier transform on 10-second segments. To evaluate the performance of OD data generation, the evaluation data includes recordings from different different dates or with different maneuver stage than the training data. In GVS, the number of components in the Gaussian mixture model was determined based on minimizing the Bayesian information criterion. The next figure shows the estimated probability density functions as generated virtual outliers for passenger ship data using VUS and GVUS. The following figure and table compare the detection performance of models trained with virtual outliers generated by VUS and GVUS using ROC curves and AUC. In these results, models trained with virtual outliers generated by GVUS consistently show higher detection performance across all data configurations. Additionally, applying GVUS to anomaly detection in images, where VUS was previously proposed and applied, showed that GVUS exhibits superior detection performance compared to VUS. To wrap things up, let me highlight the key points of our research and discuss where we are headed next. We've developed GVS, which stands for Generalized Virtual Outlier Synthesis. It's an advanced version of the traditional VUS, leveraging Gaussian mixture models to better handle the complexity of sonar signal data. Moving forward, we aim to explore new applications of OD data generation methods, specifically focusing on the classification and detection of passive sonar signals. Thank you.
네, 감사합니다. 질문 있으신 분들은 숫자 1번 키를 눌러서 마이크를 켜신 후에 질문해 주시면 감사하겠습니다. 질문 없으신가요? 네, 이상으로 질의응답을 마무리하겠습니다. 발표자분 숫자 0번 키를 눌러서 마이크를 꺼주신 후에 자리로 돌아가 주시면 감사하겠습니다. 다음으로 9번째 발표는 지구해양융합학부 해양시스템공학 전공의 고드수라브 바반 학생의 구두 발표가 있겠습니다. 발표자는 마이크 테스트 먼저 진행을 할게요. 사우룩?
Hello, sir.
Okay.
Can you hear me, sir?
Yeah, I can hear you. Can you hear me?
Okay, sir. Yes, sir. Yes, sir.
Okay. If you're ready, please start the presentation.
Okay, sir. Jungmin.
따가. Before finish, don't click back. Okay.
Hello everyone. So today I am going to present my work. My name is Saurabh, and today I am going to present my work based on triboelectric nanogenerator as title. Terminalia cebula fruits powder as a tribopositive material for high performance triboelectric nanogenerator. So these are the table of contents of my presentation. So today I will discuss about introduction of triboelectric nanogenerator and what we did. So uh, as we know, the triboelectric nanogenerator a technology that converts mechanical energy into electricity through the triboelectric effect. So when two materials come into contact with contact and separate, they separate and they generate an electric charge due to the transfer of electrons. So triboelectric nanogenerator is widely researched for as a potential energy harvesting. So here we can see in this slide, so there are four types of modes: separation mode, sliding mode, single electrode mode, and freestanding mode. And based on tank, there are so many applications such as cell power system, robotics, health monitoring, security, uh, networking, and variable electronics. So in this slide you can see the the contact separation mode and sliding mode, how to work. So so um, triboelectric nanogenerator has generated a lot of attention of developing cell power battery and battery free technology. This kind of energy harvesting device are required for the sustainable future. So in this work, we have developed the triboelectric nanogenerator by using Terminalia cebula biomaterial as a tribopositive material. So the physiochemical characterization suggests that the Terminalia cebula has hydroxyl and carbonyl group, which are important to get tribopositivity from the material. So the Terminalia cebula tribopositive material has been tested for the tank with different electronegative layer like such PET, PTFE, cellulose, lignin, and the Terminalia cebula and PTFE device exhibit higher output performance. So actually this material is like Ayurvedic medicine, like special use in homeopathy and all medicinal things. And so in this slide you can see the Terminalia cebula fruits were collected from the Maharashtra, and the collected fruits was washed by distilled water and dry in sunlight. After that, this these fruits we are using of this fruit we make powder and use as a tribopositive material. And in this slide you can see the proper device structure of the tank. The for supporting substrate we use PET, and the top and here in this second photo you can see the mechanism of the tank. There are four like in first figure 2 you can see the mechanism. And in this slide you can see the same image showing the QC porosity, which is good for our triboelectric nanogenerator. And in EDS you can show the carbon and oxygen group are present. Because of that our material is good for triboelectric nanogenerator. And here our this tank device we used using with different parameters. We use different electronegative layers, and on PTFE we got good results. Also we check forward reverse connection and power of the device, and also we check with different device size. And here you can see the 4x4 device shows good performance compared than 3x3 and 3x4. And also we check our device with the different frequencies such as 2 Hz, 4 Hz, and 5 Hz. And here you can see the 5 Hz frequency showing good performance. And lastly, our device this device we used for real-time applications such as glowing LED, and using this tank device we glowing almost 160 LEDs, and also we uh, we run the low power calculator. And these are the conclusion of my work. So Terminalia Chebula successfully demonstrate the type of positive behavior, and this device demonstrate the higher output performance and successfully operate the low power electronic devices. And the proposed device demonstrate the ability to charge dielectric capacitor. So this work we published in Energy Technology, having impact factor 3.8. Thank you. Have any question?
네, 감사합니다. 질문 있으신 분들은 숫자 1번을 눌러서 마이크를 켜신 후에 질문해 주시면 감사하겠습니다. 질문 없으신가요? Okay, thank you for your presentation.
Okay, sir. Thank you, sir.
Okay. 네, 이상으로 질의응답을 마무리하겠습니다. 발표자분들은 숫자 0키를 눌러서 마이크를 꺼주신 후에 자리로 돌아가 주시면 감사하겠습니다. 네, 다음 10번째 발표는 지구해양융합학부 해양시스템공학 전공의 고건영 학생의 구두 발표가 있겠습니다. 마이크 테스트 먼저 진행할게요. 마이크 혹시 들리시나요? 발표 자료 켜기 전에 마이크 먼저 한번 확인해 주세요. 마이크 혹시 안 들리실까요? 혹시 마이크 안 들리시나요? 혹시 마이크 세팅이 지금 안 되고 있으면은 다음 차례 발표를 하도록 하겠습니다. 고건영 학생 혹시 들리시면 그 다음 차례 발표를 해야 될 것 같아서 자리에 잠깐 앉아서 기다려 주시기 바랍니다.
아, 이거 보고 아, 네. Hi everyone, my name is Jian Jang. Today I will be presenting on the topic certification phenomenon and phytoplankton community changes on Jeju coastal waters in 2022 and 2023. First, let me briefly introduce the table of contents for today's presentation. Phytoplankton are the most important primary producers in the food pyramid of an ecosystem. They are highly sensitive to changes in environmental factors such as water temperature, salinity, and nutrient concentrations, which can significantly affect the structure of phytoplankton communities. Additionally, coastal waters are highly productive due to physicochemical factors such as the input of nutrients from terrestrial origins and overlaying processes. Jeju Island exhibits distinct physicochemical characteristics influenced by seasonal changes in currents and water masses. Every summer, high temperature, low salinity water from the Yangtze River flows into the southwestern waters of Jeju Island. This phenomenon can significantly affect the composition of phytoplankton communities. Climate change is expected to increase the discharge of Yangtze River diluted water and rise surface water temperatures. These changes are anticipated to cause significant alterations in the composition of phytoplankton communities. Thus, this study analyzes monitoring data collected from Jeju coastal waters in 2022 and 2023 to examine how variation in marine physicochemical environmental factors impact phytoplankton communities. By synthesizing these findings, the study aimed to provide a comprehensive understanding of, of the phenomena and dynamic patterns observed in the Jeju coastal ecosystem. Material and method. We conducted our research from March through August in 2022 and from March through December in 2023, with the exception of July. We utilized the Jeju National University research vessel JERA to collect seawater from a depth of 1 meter using a water sampler and measured surface water temperature and salinity using YSI and vertical water temperature and salinity using CTD. Stratification index was used to quantify the degree of stratification at each station using a stratification index. Optical microscopy was used to quantitatively and qualitatively analyze phytoplankton. Cluster analysis and RDA were used to evaluate monthly phytoplankton similarities and correlations with environmental changes. During the 2022 and 2023 service, monthly mean surface water temperature were observed in their respective ranges, with the lowest in March and the highest in August in both years, exhibiting the typical seasonal characteristic of temperate waters. Surface salinity was observed in the respective ranges, with the highest in April and in both years and the lowest August and September in the summer months, showing the opposite trend to water temperature. In 2022 and 2023, nutrient concentrations tended to decrease from March to August. However, in 2022, silicate concentrations remained in a constant range and did not show any significant changes, while in 2023, nutrient concentrations increased again, starting in September. This graph showed a vertical distribution of water temperature. They are listed in months order, with the x-axis being the peak and the y-axis being the depth. In all 2 years, the water masses were well mixed from March to May, but stratification started in June due to the increase in surface water temperature, and the stratification disappeared in October due to the decrease in surface water temperature again, resulting in vertical mixing. Here are the results of the vertical distribution of salinity, and the viewing method is same as the water temperature graph. In all 2 years, the water masses were well mixed from March to May, while stratification started in June. Vertical mixing occurred in October and was maintained until December. In particular, in July 2022, high temperature and low salinity surface water were observed from the western waters. It is difficult to conclude that the low salinity phenomenon was caused by rainfall, as rainfall was scarce before this survey, and in the case of 2022, the low salinity water was measured to a depth of 20 meters. There were also large differences in water temperature and salinity between the eastern and western peaks, suggesting that different water masses may have been present at the time. In conclusion, it is believed that the Jeju coastal waters in summer are influenced by diluted water of the Yangtze River, which is characterized by high temperature and low salinity. To quantify the degree of stratification, we calculated the stratification index for each peak by month. The analysis showed that stratification index increased toward the summer and decreased after the fall. A bar graph of the abundance of each peak by month, each station by month. In 2022, abundance was In 2022, abundance was high in the spring due to a phytoplankton bloom, while abundance decreased after the bloom ended in June when the stratified layer developed. In 2023, we found that abundance was also high in the summer. Monthly mean values of chlorophyll A compared to abundance. The yellow color indicates the abundance and the green color indicates the value of chlorophyll A, which showed a similar fluctuation pattern overall. Here is a graph showing the share of each toxin in both years the overall dominance of diatoms can be seen. Past studies have also shown a high diatom dominance in the Jeju Coast, suggesting that diatoms are the primary producers in the silicate-rich Jeju Coast. In 2022, we can see a gradual increase in the proportion of red-color flagellate algae starting in June when the water columns develops. This is an ecological strategy that utilizes diurnal vertical motions using flagella to effectively consume nutrients in the bottom layer. As a result, in the summer of 2022, the nutrients concentration in the surface layer decreased due to the strong development of the stratum due to the influx of low salinity water from the Yangtze River. This is believed to have given diatoms an ecological abundance over dinoflagellates and increased their dominance in the summer. In the summer of 2023, diatoms were dominant, which is likely due to the low amount of diluted water inflow from the Yangtze River. The following is a TS diagram of the dominant and subdominant dinoflagellates that occurred during 2022. Diatoms are colored blue and dinoflagellates are color red for easy identification. The analysis showed that the water containing turbulence are dominated by diatoms, mostly Petoceros and Skeletonema. Research of the heatmap analysis. In this graph, the top line represents the time of the month, with spring colored in blue and summer colored in red. Below that, the currents are shown in gray for the Jeju current, light blue for the Tsushima current, and pink for the diluted water of the Yangtze River. The analysis showed that diatoms such as Petoceros and Skeletonema were dominant and subdominated in the communities affected by the Jeju and Tsushima current. In the community affected by the diluted water of the Yangtze River, Petoceros was dominant and Heterocapsa appeared as an outlier. In 2023, the inflow of diluted water from the Yangtze River decreased, weakening the effect of the water mass. Therefore, we conducted a clustering analysis based on the 2023 abundance data to characterize the changes in phytoplankton communities commonly observed along the Jeju coast. Figure A is drawn with reference to B. The analysis showed that the phytoplankton community in the Jeju coast in 2023 tended to be divided into two groups. PCOA analysis showed that in 2022, the communities in April, May, and June were highly similar to each other, and the communities in July and August, which are affected by diluted water from the Yangtze River, were also highly similar. In 2023, the clusters between September and December are highly similar to each other. RDA analysis was conducted to examine the correlation between marine environmental factors and the occurrence of phytoplankton taxa. The research showed that the abundance of Dinophyta was strongly positively correlated with water temperature and SI, and negatively correlated with salinity. Bacillariophyta abundance was strongly negatively correlated with silicate, one of the essential nutrients for diatom. During the study period, Jeju's coastal waters displayed typical temperate sea characteristics. Temperature increased while salinity decreased from spring to summer. In autumn, temperature started to drop and salinity began to recover. In 2022, the strong inflow of Yangtze River diluted water intensified stratification. This stratification limited the growth of diatom and created favorable conditions for dinoflagellates such as heterocapsa and gyrodinium. In contrast, in 2023, the reduced inflow of Yangtze River diluted water led to weaker stratification. As a result, diatom were able to maintain dominance and achieve higher biomass levels. The RDA analysis revealed key relationships. It showed the negative correlation between diatoms and silicate concentrations. Meanwhile, dinoflagellates were positively correlated with both stratification and temperature. This finding emphasized the significant role of Yangtze River diluted water in shaping the marine environment and phytoplankton community around Jeju. They also highlight the importance of long-term monitoring to better understand the ecological impact of these changes, especially under the influence of climate change. Thank you.
네, 감사합니다. 방금 발표해 주신 분은 지구해양학부 지구해양과학 전공의 장지연 학생이었습니다. 질의응답 있으신 분은 마이크 1키 눌러서 마이크를 키신 후 질문해 주시면 감사하겠습니다. 질의응답 하실 분 없으시면은 발표자분은 마이크 끄시고 자리로 돌아가 주시기 바랍니다. 다음으로 고건현 학생 마이크 테스트 먼저 진행할게요. 1키 눌러서 마이크 켜주세요. 마이크 테스트 먼저 진행할게요. 세팅 누르셔서 본인 마이크 선택하고 X 눌러서 끄신 다음에 0키 눌렀다가 다시 1키 눌러서 해보실래요?
들리시나요?
네, 지금 들려요.
네.
발표
감사합니다.
자료 하셔서 한번 키시면은 끄시면 안 돼요.
네.
표지 띄워보시겠어요? 네, 잠시만요. 소개하고 시작할게요. 마지막 발표로 지구해양융합학부 해양시스템공학 전공의 고건혁 학생의 구두 발표가 있겠습니다.
Good afternoon. My name is Konyeok Ko. I will present my research on broadband matching circuit design for Janus-Elmers transducers, focusing on the development of matching circuits to enhance power factor performance for dual resonance transducers. The Janus-Elmers transducer generates significant reactive power due to its reactance component. To address this, a matching circuit is inserted between the power amplifier and the transducer. This placement optimizes the power factor, reducing reactive power and improving the overall efficiency of the system. The objective of this research is to optimize the matching circuit for the Janus-Elmers transducer. This involves matching the resonant frequencies at 508 Hz and 965 Hz, as well as improving the power factor in the non-resonant band between 600 Hz and 850 Hz. To maximize the power factor, the matching circuit minimizes the reactive component, effectively aligning the phase to 0 degrees. This ensures efficient power transfer by reducing phase discrepancies and reactive losses. Previous research on matching circuits for underwater transducers often combined transformers, inductors, and capacitors, focusing on single resonance. However, these approaches do not account for the dual resonance characteristics of Janus transducer. This study builds on these designs by introducing a dual resonant matching circuit. We designed the resonator coupling circuit that allows adjustable resonant frequencies. By tuning the coupling capacitor, dual resonances are achieved, targeting both resonant and non-resonant bands. The matching circuit structure combines RLC components to optimize power factor. A particle swarm optimization algorithm was used to fine-tune circuit components. This improved the power factor at 508 Hz and 965 Hz by 5.6% and 5.9% respectively. The optimization minimized the power factor error at these critical frequencies. To address the non-resonant band, we targeted an average power factor of 0.75 between 600 Hz and 850 Hz. This represents a 281% improvement over the baseline. Simulations confirmed phase and power factor alignment within the specified range. Simulations conducted in MATLAB Simulink validated the theoretical calculations. A 100-volt input signal demonstrated that the matching circuit achieved the desired power factor, reducing phase discrepancies across the operating range. In the non-resonant band, the active power increased by 1.13 watts or 3.6 times after matching. However, the key finding is that resistance in the matching circuit must be minimized to maintain high power delivery. This is critical because the inclusion of resistance in the matching circuit directly impacts power transfer efficiency. During implementation, deviations between theoretical and real component values affected performance. Despite these variations, the design maintains stability by keeping resonant frequencies within the target range. In summary, this research developed a dual resonance matching circuit, improving power factor performance across both resonant and non-resonant bands. Future work includes additional circuit design for weak resonance coupling and experimental verification of the circuit's performance. Thank you for your attention.
네, 감사합니다. 질문 있으신 분들은 숫자 1키를 눌러서 마이크를 켜신 후 질문해 주시면 됩니다. 질의응답 없으신가요? 질의응답 없으신 걸로 알고 마무리하겠습니다. 이상으로
여기서 사진 한번 찍고 전부 단상 위에 올라오라고.
잠시만요. 모든 참여대학원생의 구두 발표가 종료되었습니다. 발표해주신 모든 참여대학원생 분들께 감사의 인사를 드립니다. 3부 참여대학원생 구두 발표 마치기 전에 단상 지금 접속해 계신 분들 모두 단상 앞으로 나오셔가지고 사진 한 번만 찍고 참여대학원생 세션 마무리 구두 발표 세션 마무리 지을게요.
이거 백 눌러도 되나요?
네, 끄시고 요 앞쪽으로 나와주시면 될 것 같아요. 아, 저는 내가 찍어야겠구나. 지금 접속해 계신 분들 다 앞으로 나가주세요.
그냥 뭐 대충 이런 식으로 해서 한방 찍지 뭐.
앉아있는 모습 앞에서 찍어야 돼.
아니 그냥 이렇게 뭐 재밌게. 전번에 우리 그 로블록스로 한번 재밌게 찍어서 나중에 티저 만들 때 괜찮아가지고.
저 단상으로 나가주세요. 단상 앞으로. 저 모여 있는데. 네. 고준민 학생 뒤로 저 단상으로 가주세요. 천천히 나가주세요. 렉 걸리신 분들 많을 거니까.
대충 저렇게 해가지고 한방 빡 찍고. 점프.
점프. 하나 둘 셋 하면 다 점프 한번 해주세요. 하나 둘 셋.
그런 다음에 그럼 4시에 시작?
네, 구두 발표 세션 마무리하고 4시부터 포스터 세션 진행할 건데요. 포스터 세션은 포스터 발표하시는 분들 탭 누르셔서 본인 포스터 클릭하신 다음에 본인 포스터 앞에 그냥 서 계세요. 일단 포스터 클릭하지 마시고 그냥 서 계시면 제가 앞으로 가서 발표 진행하라고 하면은 그렇게 하시면 될 것 같아요. 첫 번째 조성현 학생 먼저 할 거니까 조성현 학생 먼저 마이크 테스트 하고 진행할게요. 4시에 진행하겠습니다. 잠시 휴식 시간 갖고. 포스터 발표하시는 분들은 본인 포스터 앞에 서 계세요. 4시에 뵙겠습니다.
준비됐습니다.
포스터 세션 진행하도록 하겠습니다. 지구해양융합학부 지구해양과학전공 김희아 지상하 학생 먼저 발표 시작하겠습니다. 발표 진행해 주시면 됩니다.
네. Hello everyone. Today I will introduce our study on the impact of aquaculture activity on water quality. We conducted 24-hour continuous investigation at a flow-through aqua farm during both normal feeding and fasting period to analyze water quality changes and potential contamination. Key parameters measured were total dissolved nitrogen and dissolved organic carbon to assess contamination levels. To further characterize the organic matter, we analyzed color and fluorescent dissolved organic matter. Using parallel vector analysis, the major fluorescent components of effluent were identified and categorized into protein-like and humid components. Our result showed significant increase in effluent compared to effluent water. TDN increased by 3.5 times, DOC by 1.3 times, Fton by 2.3 times, and Cdon by 1.7 times. These increases are likely due to excess feed residue and the metabolic activity of aquaculture organisms. We also found a strong positive correlation between Fton and DOC, indicating that the optical properties of organic matter can serve as a reliable indicator for monitoring water quality in aquaculture systems. Thank you for your attention.
네, 감사합니다. 다음으로 김희아 학생 발표해 주세요. 고건혁 학생 캐릭터 좀 딴 데 중앙으로 이동시켜 주실래요? 네. 네, 다음으로 지구해양융합학부 지구해양과학전공 김희아 학생 발표 시작하도록 하겠습니다. 준비된 대로 바로 발표 시작해 주세요. 네, 바로 시작하세요. 잠시 마이크가 엄청 끊기거든요. 한번 체크해 주실래요?
혹시 지금 괜찮으세요?
지금 계속 끊기거든요. 0번 눌렀다가 1번 누르셔서 다시 한번 마이크 껐다가 켜주세요.
괜찮으세요?
계속 끊기긴 하거든요.
계속 지금 스피커만 바꿔 하시겠습니다.
네, 알겠습니다.
지금 괜찮으실까요?
잠시만요. 계속 끊기거든요. 똑같은 잠시 지금 포스터 쪽 화면 보고 제 캐릭터가 지금 괜찮으시죠? 지금 괜찮거든요.
네, 그럼 지금 발표 다시 하겠습니다.
네.
I will present a change in nutrient flux from submarine groundwater discharge caused by a typhoon event in Jeju Island, Korea. Changes in the intensity and frequency of typhoon due to climate change and global warming can significantly impact coastal groundwater dynamics. Therefore, this research was conducted to analyze the mixing pattern between groundwater and seawater before and after the typhoon, as well as to assess the typhoon's effect on coastal groundwater and nutrient dynamics. I conducted a sampling campaign around the coastal area of Jeju Island before and after Typhoon Hinnamnor. Before the typhoon,
dissolved inorganic nitrogen, dissolved inorganic phosphate, and dissolved silicon exhibited a significant negative correlation with salinity, indicating a conservative mixing of groundwater and seawater. After the typhoon, it was found through a DSI mass balance model that groundwater seepage rate increased by approximately sevenfold. However, the correlation between salinity and nutrients weakened after the typhoon, likely due to the rapid mixing of groundwater and seawater in the submarine estuary. This study provides important insights into understand the impact of typhoons on coastal groundwater and nutrient dynamics. Should the intensity and frequency of typhoons increase due to climate change, such coastal groundwater seawater mixing phenomena may occur with greater frequency. 네, 발표 끝났습니다.
감사합니다. 접속 종료해 주셔도 괜찮습니다. 다음으로 마이크 연결되신 분들, 아무나 발표자분들 중에 마이크 연결되신 분들 마이크 테스트 해 주실래요? 고준빈 학생 마이크 연결돼 있나요? 조성현
들리시나요?
네, 들립니다. 그럼 고준빈
네.
학생 먼저 진행할게요. 포스터 앞으로 이동해 주세요.
네.
잠시만요. 저도 이동을 해야 돼서. 아, 이거다. 소개하고 진행할게요. 위치해 주세요. 다음으로 지구해양융합학부 해양시스템공학 전공 고준빈 학생 발표 시작하도록 하겠습니다. 네, 시작해 주십시오.
네. In this study, it was especially focused on targeting specific brain regions in both clinical and research environments. There are limited real-time monitoring tools that are easily accessible. To address this, we developed a Matplotlib-based guidance system for tracking the focused ultrasound transducers focal point in real time during porcine brain experiments. In the experimental setup, the skull volume of the porcine skull phantom was reconstructed from pre-scanned CT images and visualized in a virtual environment. A 3D model of the FES transducer was constructed using 3D CAD software to align and visualize the transducer's position relative to the skull volume. A passive optical marker was attached to the transducer, allowing real-time tracking by an optical camera. A custom GUI program was developed to process the location data provided by the optical tracking system, translating the real-time position of the transducer into the virtual environment. After registering the skull volume with the FES transducer, the software visualized the FES focal point over the pre-scanned CT images, enabling precise guidance and tracking during the experiment. The system's accuracy was validated using fiduciary registration error and target registration error. FRE measured by comparing three virtual and physical fiduciary markers had a mean ranging from 1.7 mm to 1.8 mm, with a minimum of 0.46 mm and a maximum of 2.91 mm. PLE, which assesses the accuracy of targeting arbitrary points, showed a mean of 2.01 mm with errors ranging from 1.11 millimeter to 3.05 millimeter. This research demonstrates that the system archives precise tracking with that slightly higher error when targeting arbitrary points. This open source framework is designed from ease of use and customization, and finally, this system will be used for transgenic Alzheimer's disease pig model. Thank you.
네, 감사합니다. 발표하신 분들은 접속 종료하셔도 상관없습니다. 그 다음으로 조성현 학생 마이크 테스트 해주세요. 조성현 학생. 조성현 학생 마이크 연결 안 된 것 같거든요. 지금 누구시죠?
신시 학생 잠깐 마이크
신시 학생 먼저 그냥 진행할게요, 바로.
네.
네, 다음으로 지구해양융합학부 해양시스템공학 전공의 신시아 학생 발표 진행하겠습니다. 바로 발표 진행해 주시면 됩니다.
Hello, my name is Cynthia Das and I am from Ocean Biomedical Ultrasound Lab. Today I will present about my poster, and my poster is related to the therapeutic effect of focused ultrasound and delivery of ginseng nanoparticles in Parkinson mice. As we know that the therapeutic ultrasound has potential for non-invasive opening of the blood-brain barrier and therapeutic facilitation of therapeutic agents to the mice brain. In Parkinson's disease, there is neuroinflammation inside the brain, and the blood-brain barrier is the potential challenge for us to deliver the drugs to the brain. Our research focuses on the temporary disruption of the blood-brain barrier and the delivery of ginseng nanoparticles for the curation of the Parkinson's disease. In order to do that, our research focuses on the transducer, the high transducer, and we used 1 megahertz transducer with 0.3 megapascal pressure to open temporarily the blood-brain barrier of the mice brain. In order to do that, we first calibrated our transducer in open field and checked the pressure for different voltages. And next we made a rotinome model of Parkinson's disease, in which a C57BL6 mice were used and were injected with 3 mg per kg daily of intraperitoneal rotinone for 28 days to replicate the Parkinson's disease model. And their behavioral test is monitored daily in order to check the progression of the disease. Along with that, we do biomarker analysis to check for the neuroinflammation rise in the Parkinson mice model. The next, we have to do the acoustic characterization of the focused ultrasound in order to check the focal depth, pressure, and the focal attenuation of using the mice skull in vitro. Next, we demonstrated the stable and inertial cavitation dose. Since microbubbles have potential to damage the mice brain, so we have to check in vitro the potential of the focused ultrasound. In this, we found that the inertial cavitation dose is around 0.5 megapascal, and then we check this dose inside the mice brain. For experimental purpose, we opened the BBB for C57BL6 mice of 30 grams using 1 megahertz transducer, in which we gave the 150 microliter of Sonoview microbubble through mice tail vein and intravenously injected the fluorescently labeled ginseng nanoparticles. Our future work includes the therapeutic application of this ginseng nanoparticles for reducing neuroinflammation and curation of the reactive oxygen species inside the mice brain of Parkinson's disease. Thank you.
발표해 주셔서 감사합니다. 접속 종료해 주셔도 괜찮습니다. 다음으로 마이크 연결되신 분 바로 테스트 한번 진행해 주세요. 마이크 되시는 분들 먼저.
제 말 들리시나요?
네. 고영빈 학생 맞으신가요?
네, 고은비 학생입니다.
네, 본인 포스터 앞에 위치해 주세요. 왼쪽으로 가요. 첫 번째 거. 고영빈 학생 포스터 이쪽에 있어요. 네. 소개하고 시작할게요. 다음으로 지구해양융합학부 해양시스템공학 전공의 고영빈 학생 포스터 발표 진행하겠습니다. 발표 바로 진행해 주시기 바랍니다.
Yeah, hello, my name is Yongbin Ko from the Faculty of Arts of Marine Competence at Jeju National University. Today I'm going to present on the topic of real-time smart aquaculture monitoring system based on digital twin. Aquaculture is a crucial industry globally to meet the growing population and increasing demand for food. Leveraging marine resources has become essential. During the food supply, aquaculture plays a pivotal role in economic growth and environmental preservation. However, traditional aquaculture systems face several significant challenges. First, aquaculture facilities need to monitor diverse environmental parameters such as temperature, dissolved oxygen, and water quality. However, comprehensive analysis and management of such data are often difficult. Second, without proper visualization, managers struggle to intuitively understand the environmental data. This often leads to delays in detecting environmental challenges or responding effectively during crucial situations. To address these challenges, smart aquaculture technology has been actually researched. Among these, this twin technology demonstrates great potential by creating a virtual replica of aquaculture facility, significantly improving management efficiency. This research originates from the need to leverage such advanced technology. The digital twin aquaculture system focus on three core objectives. First, it ensures efficient environmental data management by using IoT sensors to collect real-time data and integrating it into a centralized platform for streamlined decision making. Second, this enables intuitive data visualization through the digital twin platform that simplify the interpretation of complex environmental conditions. Finally, the system supports maintenance crisis response with warning alarm system to detect and address risk promptly, improving both food productivity and operational stability. Digital aquaculture system replicate real-world aquaculture environment through three components. The IoT system collects environmental data such as temperature and dissolved oxygen using sensor transmitting it via Wi-Fi to NAS for storage and visualization. Collected data are processed in real time with relevant information filtered out to ensure managers focus on critical insight. Finally, the digital interface is developed using Unreal Engine to create the physical structure and conditions of the aquaculture facility in a virtual environment. The digital twin approach system is a key feature of digital twin platform, designed to visualize not stored data within the interface and facilitate periodic monitoring via flame monitor. Using a multi-layer perception model, the model analyzes encounter data and classify risk level into three categories: safe, warning, and danger. For example, it triggers alert when water temperature exceeds a defined threshold or dissolved oxygen drop, enabling manager to assess condition and respond promptly. Beyond the visualized data, this system supports data-driven decision-making by predicting environmental change, empowering managers to act proactively. Ultimately, it enhances both the stability and productivity of virtual facilities. This study successfully developed a system that integrates the system platform with IoT technology to enable real-time monitoring and visualization of environmental data in aquaculture facility. This system provides an intuitive way to manage and visualize complex environmental data, significantly improving operational efficiency. Additionally, the system includes a warning alarm feature that allows for early detection of environmental risk, enabling managers to respond quickly and efficiently to critical situations. By supporting better decision making and minimizing risk, the system enhances both the productivity and stability of aquaculture operation, contributing to sustainable development of the fisheries industry. The digital aquaculture system allows the full intuitive management of complex environmental data and provide the tools needed to respond rapidly to critical situations. This technology represents a significant step forward in enhancing the efficiency and stability of the aquaculture operation. Moving forward, it is expected to play a key role in the sustainable future of the fisheries industry. Thank you for your attention.
네, 감사합니다. 발표하신 발표자분은 접속 종료하셔도 괜찮습니다. 다음으로 마이크 연결되신 분 마이크 테스트 한번 진행하고 성함 말씀해 주세요.
혹시 들리나요?
네, 잘 들립니다.
네, 한현주랑 그다음에 비자얀 바로 다음에 할게요.
네, 한현주 학생 먼저 잠시만요. 제가 한현주 학생 본인 포스터 앞에 안 계시는데요?
저 그 센틸 캐릭터로 접속해 있어요.
본인 캐릭터는 지금 로그인 안 되나요?
네.
네, 일단 알겠습니다. 옆으로 오른쪽으로 서 주실래요? 네네. 네네네네. 소개하고 바로 시작할게요. 다음으로 지구해양융합학부 해양시스템공학 전공의 한현주 학생 포스터 발표 시작하겠습니다.
네. Hi, I'm Hyunju Han. I'm going to share an overview of my research, which focuses on wave interactions with pile-reinforced seawall structures using TSP circular piles. We investigate the wave pressure and wave height distribution around seawall constructed with an array of TSP circular piles. Using an eigenfunction expansion method, we analytically model the interaction between waves and piles, considering wave deformation and force distribution across the pile groups. The result aligned well with experimental data, demonstrating the accuracy of this approach. TSP piles offer several advantages they significantly reduce construction time and improve stability on soft seabed, making them a viable alternative to traditional concrete seawards. And their porous nature helps dissipate wave energy, reducing wave load on the structures. We examined the effect of pile permeability using Darcy's law and studied the behavior of regular waves interacting with cylindrical piles in various configurations. This required deriving and solving equations involving Bessel and Hankel functions to represent the fluid behavior. Both analytical models and wave tank experiments were employed, showing good agreement in result. Wave forces decrease as the spacing between pile increases, particularly for long-period waves, where wave energy escapes through the gaps. However, short-period waves are trapped within the pile array, leading to localized amplification of wave forces. The shape and arrangement of piles significantly influence wave reflection coefficient and run-up amplification factors. Moreover, we propose a prefabrication method for TSP piles that allows for efficient assembly and installation in weak soils, enhancing construction efficiency and structural stability. This study not only validates the feasibility of TSP piles in coastal engineering, but also highlights the need for future research into nonlinear and turbulent effects to address the complexities of irregular wave behavior. In conclusion, this research provides a pathway for improving the design and construction of resilient coastal structures while reducing environmental and economic impacts. Thanks for listening my short presentation. 끝났어요.
네, 감사합니다. 발표자 지금 비자연 학생 그 센터 캐릭터로 바로 진행하실 건가요?
네, 가능해요.
비자연 아이디가 접속이 안 되시는 건가요? 아니면 그냥 한 번에 하려고
지금
그러시는 거죠?
지금 헤드폰이 제 거밖에 안 돼가지고.
네, 일단 알겠어요. 비자연 포스트 앞으로 가주세요.
네.
여보세요? 제 말 들리시나요? 마이크 꺼지신 것 같거든요. 내 말 들려?
Hello.
네, 제가 소개하고 이 앞쪽 한번 봐.
Can you hear me?
Okay, I hear.
Okay.
Look at me, please.
Yes. Can I start?
캐릭터 디렉션
Look at me.
change.
네, here.
Your character direction.
BJ.
Yes, Vijay.
Move.
Look at me.
I'm actually from the Sendil's account.
You stand on CR1.
여보세요?
날 봐줘, 현주야.
네.
내 캐릭터를 봐줘. 똑같이.
됐나요?
네, 제가 소개하면은 바로 시작하시면 됩니다. 다음으로 지구해양 융합학부 해양 시스템 공학 전공의 비자연 학생 발표 시작하도록 하겠습니다. 발표 시작해 주세요.
Can I start?
Yes.
Okay, myself Vijayendra Hari Vijay, and today I'm going to present the oscillating buoy integrated into a fixed oscillating water column for a sustainable renewable energy generation. Oscillating water column is a wave energy converter which consists of a oscillating water column, that is it consists of a chamber, some air is trapped inside. As you know, the wave propagates. The wave has up and down movement. When the waves moves up, the air trapped in the oscillating water column chamber will get pressurized, and it is allowed to pass through the hole which is attached with the air turbine. When the air pass through that air turbine, it will rotate and it can be converted to electricity. That is the oscillating water column. Another wave energy converter is used as the oscillating buoy. Oscillating buoy is nothing but a body that is allowed to move up and down, and this translation motion can be converted into electricity using some power takeoff unit. So this both wave energy converters are used to produce electricity by combining them. So this is done by the StatCCM plus CFD software. So when we go to the mathematical formulations, we are going to find out the oscillation motion, that is a heave motion of the oscillating buoy, because the another motion is constrained, and then we have to find out the natural frequency, then optimal PTO damping efficiency. Thereby we can find out the incident wave power and output wave power. So the conversion efficiency of the combined wave energy converters, that is the oscillating buoy and oscillating water column, can be calculated. When we go to the numerical model, the figure 1 shows the two bodies situated in the wave tank, that is numerically modeled in StatCCM plus, and the first body is oscillating buoy, and it is allowed to move up and down only. And another body is the oscillating water column. Oscillating water column is fixed on the seabed, and the seabed is allowed. Seabed is assumed to be uniform. And as I said earlier, the oscillating water column consists of a chamber that in that the air is trapped. So when the wave moves up, the air gets pressurized and it flows through the hole to run the turbine, and thereby producing the electricity. So for in the chamber, we are providing number of pressure probes to find out the pressure inside the chamber for the further investigation, and wave probes are provided to find out the wave elevation. Figure 2 shows that the mesh flow and the offset mesh is given for the movement of the oscillating buoy and oscillate. Okay, another one is the damping zone. Damping zone is used to reduce the reflected waves effect. So then we go for the numerical domain with the boundary conditions applied in the figure 3. You can see then figure 4 the vorticity formation. Thereby you can see that the oscillating buoy and oscillating water column is combined together. You can see the air movement through the hole inside the hole from the chamber. So here what we had done was two models have been created. The first model was with only OWC, that is oscillating water column. Then find out the then I had to find out the pressure inside the chamber using the pressure probe, and this pressure is validated using the experimental data from Chen's experiment. And after the validation, I have incorporated an oscillating buoy with the oscillating water column. So then I have conducted experiment. I have conducted the experiment through the simulation by incorporating the both the wave energy converter. Will it improve the efficiency or not? So so by the experiment from the figure 5, we can see that the result shows that by incorporating the oscillating buoy with the oscillating water column, the conversion efficiency of the total both the wave energy converters can be improved. Instead of providing the wave energy converters individually, if we combine together, we can improve the efficiency of the conversion efficiency of the wave energy converter. So this is when you talk about the conclusion, the combined wave energy converter, that is the oscillating buoy and the oscillating water column hybrid version, is more effective than which is using individually. So that's my presentation. Thank you.
네, 감사합니다. 발표자분 프로그램 종료하셔도 괜찮습니다. 다음 발표자분 마이크 테스트 한번 시작할게요. 마이크 되시는 분 아무나 마이크 켜서 테스트 진행해 주세요.
혹시 들리나요?
네, 들려요. 왕욱 학생 맞죠?
네, 맞습니다.
잠시만요. 제가 위치하고 소개하면은 발표 시작할게요.
네.
네, 다음으로 지구해양융합학부 지구해양과학 전공 왕욱 학생 발표 시작하겠습니다. 발표 시작해 주세요.
Hello everyone, my name is Wang Wu. Today I'm honored to share our findings on two diatom space discovered along the coast of Jeju Island. Student share around Humia previously unrecorded in Korea, and a potential new space student share SP. Student share is a diatom genus known for producing democratized neurotoxin responsible for harmful gallblains. These blooms can harm marine ecosystems and human health. As they in Canada, poisoning ingredients that resulted in fatalities and over pie illnesses. Despite this, research on student share in Korea has been limited. From March 2022 to April 2024, we collected samples from 12 stations along Jeju Island using the research well so Taylor we identified 64 terrains across 8 species, including student share Rondhumia and student share SP. Morphological and molecular analysis confirmed student share Rondhumia matches the documented strains, where student CRSP showed this tweaked characteristics compared to related species like student CR brasiliana. Both species product domo acted student CR Rondhumia generated 1.89 picograms per cell during the E1 perhaps, while student CRSP produced 7.84 picograms during the S1 perhaps. In summary, this study provides the first clear record of student share Rondhumia and identifies for potential new space. This finding stressed the need for ongoing monitoring of student share to better manage harmful illegal blooms and protect marine ecosystems. Thank you for your attention. 감사합니다.
네, 감사합니다. 발표자분 접속 종료하셔도 괜찮습니다. 다음 발표하실 분 마이크 켜서 마이크 테스트 진행해 주세요.
저 혹시 발표해도 될까요?
네, 김진승 학생 이성빈 학생이신가요?
아, 예, 맞습니다.
잠시만요. 네, 뒤로 조금만 가주실래요?
예, 잠시만요.
네네네. 소개하면은 바로 발표 시작해 주시면 돼요. 다음으로 지구해양융합학부 지구해양과학 전공의 이성빈 학생 발표 시작하도록 하겠습니다.
Hello, my name is Seongbin Lee. I will present to my study. The title is Analysis of Improvement Coastal Meteorological Predictions using coupled atmosphere ocean data simulation and machine learning techniques. This study investigated the impacts of coupled atmosphere ocean data simulation and tidal effects on meteorological predictions along the west coast of South Korea during the winter and spring of 2019 using a coupled atmosphere ocean modeling system. To enhance predictions, we employed 5 machine learning models: random forest, extreme gradient boosting, support vector machine, artificial neural network, and K nearest neighbor. Overall, the simulation results that included DA and tidal effects, TD simulation for the winter and spring case exhibited good agreement with meteorological observation, especially relative humidity RH and air temperature temp, compared to simulation without these consideration and TD simulation. In addition, the machine learning prediction results for both winter and spring case showed lower errors in wind speed and RH compared to the TD simulation, with significant improvements in the overestimation of WS through the machine learning models. In addition, using the Shapley additive explanation SHAP approach in XGBoost and RF models, wind speed and wind direction and dew point temperature were identified as the key input variables for predicting WS and RH in the target area respectively. Thank you.
네, 감사합니다. 발표하신 분은 접속 종료하셔도 됩니다. 다음으로 발표하실 분 마이크 키셔서 바로 테스트 먼저 진행해 주세요. 마이크 연결되신 분 바로 말씀해 주세요.
Hello, can you hear me?
Yes. What's your name?
Hello, my name is Abdul Mannan, and I'm from Ocean System Engineering, and my lab name is Ocean Information System Engineering, Professor Jinhobe. Today, my topic of presentation is the miniaturization power and harnessing of micro supercapacitor for advanced microelectronics devices. And basically, this novelty work on the how the micro supercapacitor is integrated with energy technologies and the microelectronics devices. Basically, what is micro supercapacitor? Micro supercapacitor is nothing but the energy storage device, and which is store energy. And early, I want to describe how to micro supercapacitor harnessing the advanced form of supercapacitor. And in this work, we focus basically on 3 parameters. Firstly, we first time define the give the definition of micro supercapacitor. Actually, what is the micro supercapacitor? Before this, there is no authentic definition about the micro supercapacitor. Here you see the figure in which figure 1, and in which we describe the strength, weakness, opportunities and threats for the micro supercapacitor in microelectronics devices. The first one is that the micro supercapacitor threat are the its market competition and degradation and material selection. Until now, the different techniques are applying for betterment of its how to better the material and how the degradation value and manufacturing techniques. In detail review, we describe everything about how to material select, and in the second, in which different on the electronic devices and attach and material and methods part, in which we describe in figure how we define the micro supercapacitor. Basically, the micro supercapacitor is the device, energy storage device, which store energy. And second thing is that the micro supercapacitor definition, it's three parameters which describe the definition of micro supercapacitor. Just there the width of the electrodes and what is the length, and the three parameters describe. And we describe about the, and the second one, what different types of material until now, carbon based material, and now people are working towards the hybrid materials and magazine based material MOFs, and how the different techniques are applying for the betterment, and what kind of structures and techniques are required to favor betterment the performance. And most important part of this article, in which the different microelectronics devices are attached, and see the results, and how these techniques and how this study further proceed. And we are going towards the hybrid system, in which only a one system in which energy generation, energy storage, and energy utilizing devices are used. This is my work which I describe in front of you. Thank you very much.
네, 감사합니다.
감사합니다.
발표하신 분은 접속 종료하셔도 괜찮습니다. 다음으로 발표하실 분 마이크 키셔서 마이크 테스트 먼저 진행해 주세요.
들리시나요?
지금 말씀하신
들리시나요?
분 누구죠? 마이크가 좀 소리가 되게 작거든요. 누구시죠?
들리시나요?
들리는데 소리가 굉장히 작아요. 강주의 학생 맞나요?
다시 한번 말씀해 주세요.
마이크 연결되신 분 아무나 말씀해 주세요. 준비되신 분부터 발표하겠습니다.
가가지고 마이크 키고 이야기하는 그쪽으로 갈게요.
지금도 안 들려. 혹시 들리시나요?
네, 들리는데 소리가 좀 작거든요.
소리요. 잠시만요. 이거
네.
볼륨. 아니. 혹시 괜찮으신가요?
그대로긴 한데 저희가 나중에 편집해서 소리 올릴게요. 제가 소개하면은 발표 시작해 주세요. 다음으로 지구해양 융합학부 지구해양과학 전공 조성현 학생 발표 시작하도록 하겠습니다.
발표 시작하도록 하겠습니다. Hello everyone. The title of my research is the role of the South Pacific subantarctic water in the Southern Ocean context increase since 2005. Since the Industrial Revolution, the amount of CO2 released into the atmosphere has been continuously increasing. As a result, a significant portion of excess heat energy has been absorbed by the ocean. One of the key masses responsible for transferring heat from the atmosphere to the ocean is the subantarctic mother water. The mother water forms in high latitude regions where its subduct slowly moves in meridional directions. During this process, it absorbs heat from the atmosphere and transports it into the layer of the ocean, and playing a crucial role in ocean heat uptake is redistribution. This characteristic of mother water is known to reduce the energy retained in the atmosphere, thereby suppressing the effect of warming in the short term. However, little is known about the long-term mother water, raising several questions. How are the heat contents of mother water evolving over time? And will mother water continue to effectively absorb heat from the atmosphere in the future? To address this study means how the contents of mother water has changed since 2005 and explores its influence on ocean beds. For the past 30 years, the global ocean heat has increased by approximately 10 zetajoules per year. The southern ocean accounting for 20, half, one half of this increase. Notably, studies indicate that the subantarctic water has contributed to about 6% of heat content increase in southern ocean, and highlighting its crucial role in ocean heat uptake. To analyze the characteristics of water and heat contents, we separate its increase into two components: the contribution from volume expansion and the contribution from temperature. The results show that the majority of heat contents increase was explained by volume expansion rather than direct warming. This trend is most pronounced in Pacific Ocean, whereas distribution from volume expansion were relatively minor in other basins. This suggests that heat is continuously accumulating in regions where Pacific water is located. To understand what has driven this significant heat content increase due to volume expansions in oceans, we examine change in atmospheric forcing over study period. The results show that greater heat divergence occurs in the where Pacific warm water is located. Additionally, the strengthening of the weather winds that highlighted enhance the transport of heat into the region where most forms. This suggests atmospheric forces played a crucial role in driving increasing heat content through volume expansion in the Pacific subarctic model water. Thanks for hearing. This is my short presentation.
네, 감사합니다. 발표자분 접속 종료하셔도 괜찮습니다. 고지연 학생 조명 때문에 그런 것 같아요. 고지연 학생 마이크 연결되어 있나요? 마이크 연결되신 분들 아무나 말씀해 주세요. 제가 앞으로 갈게요. 포스트 앞에 계시면.
인현이 들리시나요?
네, 들려요. 잠시만요. 제가 이동 좀 할게요. 뒤로 조금만 가주실래요? 네, 포스터 오른쪽에 서 계세요. 네, 그러고 저 쳐다보시면 돼요. 네. 제가 소개하면 발표 바로 시작하시면 돼요. 다음으로 지구해양융합학부 지구해양공학 전공의 임현희 학생 발표 진행하도록 하겠습니다. 잠시만요. 지금 좀 많이 끊기거든요. 소리도 좀 작고. 다시 마이크 테스트 한 번만 진행해 주세요.
네.
소리가 잘 안 들리는데 그 포스터 보고 한번 말씀해 보실래요? 그러면? 네, 그쪽 저 쳐다보지 말고 다른 데 보고 말씀해 보실래요? 한번 말씀해 보세요.
또 끊길까요?
지금도 좀 끊기거든요. 사무실 내려와서 발표하실래요?
네네.
바로 세팅해 놓을게요. 다른 분 마이크 되시는 분 마이크 테스트 한번 해주세요.
들리시나요?
네, 들려요. 누구시죠? 고지연 학생인가요?
네, 고지연입니다.
잠시만요. 제가 앞으로 갈게요. 고지연 학생 혹시 저 한번 쳐다봐 주실래요? 이쪽 한번 봐봐 주실래요? 앞에 있어요. 네. 뒤로 조금. 네네. 그러고 그 상태에서 저 쳐다봐 주세요. 마이크 테스트 한 번만 해주세요. 마이크 테스트 한 번 더.
들리시나요?
네, 잘 들립니다. 제가 소개하면 발표 바로 시작하시면 돼요.
네.
다음으로 지구해양융합학부 지구해양융합학부 지구해양과학전공 고지연 학생 발표 시작하겠습니다.
Hello everyone, my name is Go Jiyeon and I'll be presenting on the topic of the lagged impact of deepened emergency law on summer CIS through enhanced CIS experts and ice ocean availability feedback. Antarctic CIS plays a crucial role in the Antarctic region and Earth's climate, influencing ocean atmosphere interaction, ice shelf stability, ice mass balance, ocean circulation, and the Earth's radiation. Antarctic sea ice extent has shown a gradual recovery trend since the abrupt reduction in sea ice extent in the mid-2000s. Since spring 2021, sea ice extent started to decline again and has remained low since then, resulting in record low summer minima. Using satellite observations of sea ice and atmosphere reanalysis data, this study analyzed the spatio-temporal evolution of Antarctic sea ice from March 2021 to February 2023 and investigated how preceding atmospheric patterns contributed to significant decrease in sea ice extent on seasonal scale. In these years, the deepening of the emergency law caused unusually strong southerly winds anomaly over the Ross Sea, which carried sea ice northward, but in the Weatherly Sea, it produced northerly wind anomalies which reduced sea ice. Persistent and strong southerly winds anomaly pushed sea ice northward from the Ross Sea coast. This process promoted the development of falling ice and thinned the coastal sea ice. As a result, the increased solar radiative energy during the summertime further accelerated the melting of coastal sea ice, leading to the record low summer sea ice. Analysis of the EOF, or upper level geopotential height, suggested that seasonal variation of emergency low over the 2 years, especially in the preceding winter and spring, largely influenced by the leading modes of Southern Hemisphere, Southern Atlantic, and the Pacific South American pattern, thereby playing a major role in changes in Antarctic. Furthermore, given that air and upper ocean temperature in Southern Hemisphere have been persistently increasing, particularly since 2006, it is likely that atmosphere and upper ocean warming have also contributed to recent record low summer minima. Thank you for attention. 이상입니다.
네, 감사합니다. 발표하신 분 접속 종료하시면 됩니다. 그 다음으로 이면희 학생 시작할게요. 잠시 소개 먼저 하면은 바로 시작해 주시면 돼요. 다음으로 지구해양융합학부 지구해양융합학부 해양시스템공학 전공 임현희 학생 발표 진행하도록 하겠습니다.
My name is Hyunhee Im from the Department of Ocean System Engineering, and I will be presenting on the topic of underwater ship engine sound classification using tensor factorized neural network. In previous studies on underwater ship engine sound classification, features were primarily extracted using spectrograms generated through short-time Fourier transform. However, fixed parameters defined in the STFD process, such as a single window size, have limitations in sufficiently reflecting the temporal and the frequency resolutions required for classification. To overcome this limitation, our study proposes leveraging multi-resolution spectrograms generated using various window sizes as featured. We also propose a tensor factorized neural network to process these features for improved classification performance. Our Our method involves generating multi-resolution spectrograms using short, medium, and long window sizes to capture diverse temporal and frequency resolutions. The resulting spectrograms are represented as a 3D tensor consisting of the frequency, time, and window size axes. The proposed TFNN utilizes Thakor decomposition to gradually reduce or transform the dimensions of the tensor, while extracting intrinsic features. By employing weight decomposition along its axis, TFNN efficiently learns the most important features, while simultaneously reducing the number of parameters. This approach enhances classification performance while maintaining computational efficiency. This study was conducted on 5 ship types from the ship year database, including motorboat and passengers. For each class, we used 400 training samples and 80 testing samples, and the STFT was applied using window sizes of 512, 1024, and 20,048, resulting in a 3D tensor representation. The model was trained for a total of 300 epochs using the Atom optimizer. The loss value stabilized after approximately 200 epochs, showing a gradual decrease over the course of training. When comparing the classification across of existing models and the proposed TFNN achieved a minimum improvement of 4.45% over the existing methods, demonstrating superior performance. The confusion matrix revealed that most classes exhibited high diagonal values, indicating excellent classification across all the proposed model. In conclusion, by utilizing multi-resolution spectrograms and the proposed tensor factorized neural network, we achieved higher classification across compared to traditional models. Furthermore, the use of Thakor decomposition enabled efficient feature learning while reducing the number of parameters. For future work, we plan to explore graph-based tensor vectorization methods and incorporate data augmentation techniques to further improve classification performance. Thank you for listening.
네, 감사합니다. 발표하신 분은 접속 종료해 주셔도 괜찮습니다. 그 다음으로 이나연 강주의 학생 마이크 테스트 하고 마이크 테스트 해주세요. 이나연 강주의
들리시나요?
네, 지금 이나연 학생이신가요?
강주혜.
잠시만요. 제가 앞으로 갈게요. 뒤로 조금만 가주실래요? 네네. 뒤로 좀 간 다음에 저 쳐다보세요. 봐주세요. 네, 제가 소개하면은 바로 발표 진행해 주시면 됩니다. 다음으로 지구해양융합학부 지구해양과학전공 강주혜 학생 발표 시작하도록 하겠습니다.
Hello everyone, I'm Kang Jue and I will be presenting on the topic of characteristics of global sea-level change learning in the period. While global mean sea level is a direct consequence of
잠시만요. 지금 마이크 많이 끊겨가지고.
네.
여보세요?
네.
네, 뒤로 좀만 가신 다음에 저 안 보이게끔 시야한 다음에 한번 해보시겠어요? 한번 다시 해보시겠어요? 네, 여보세요? 여보세요?
네.
네네네. 네. 너가.
Hello everyone, I'm Kang Jue and I will be presenting on the topic of global sea level change learning in the period. While global mean sea level is a direct consequence of ongoing global warming, natural climate variability such as El Niño and La Niña can result, global sea level rise above temporarily. During the period, global mean sea level can rise due to change in thermal expansion and ocean mass. Previous studies have shown that internal variability in global mean sea level are closely related to ENSO. However, the contribution of thermal expansion and ocean mass to global mean sea level and their temporary variability have remained unclear. To do so, we use satellite, space-based, and cargo-based data from 1993 to 2022 during the period to identify the characteristics of global mass and ocean density contributing to global mean sea level and examine the contribution of each process to global mean sea level change. The results show that the internal variability of global mean sea level is highly correlation with ocean mass change caused by landwater storage, which contributes a larger amount to global mean sea level than ocean density driven static sea level change. Static sea level exhibits significant regional variation, representing the distinct type of pattern of the tropical Pacific sea level during the ENSO period. Landwater storage patterns indicate negative anomalies of more than -5 cm in Indian, Eastern China, and North-South America, and positive anomalies of more than 5 cm in the southern China and southeastern America during El Nino period. During La Nina period, the opposite pattern was observed in this region. The global landwater storage and land precipitation showed similar patterns to the landwater storage during the ENSO period. This concludes the presentation of my research. Thank you for listening. Thank you.
네, 감사합니다. 접속 종료해 주셔도 됩니다.
네.
다음으로 이나연 학생 준비되셨을까요?
네.
이나연 학생 혹시
혹시
마이크
들리시나요?
준비되셨나요? 네네, 들려요. 혹시 조금만 뒤로
네.
가주실 수 있을까요?
뒤로요?
네, 포스터 쪽으로 가주시면 될 것 같아요. 네, 저쪽을 좀 봐주시면 제가 소개하고 바로 시작해 주시면 됩니다. 지금 마이크 준비되셨을까요?
네.
네, 시작하겠습니다. 네, 다음으로 지구해양융합학부 지구해양 전공의 이나연 학생의 발표가 있겠습니다.
Hello everyone, my name is Naomi and today I will present my research on evaluating signal-shield uptake in symmetric growth models, focusing on the Northwest Pacific Ocean, a key region in the global carbon cycle. Understanding how ESMs reproduce CO2 uptake is essential for assessing the accuracy of climate projects. Our study evaluated the past reproducibility of chlorophyll concentrations and particle pressure of CO2 using data from collecting ESMs participating in symmetrics. To reduce uncertainties, we created a multimodal ensemble based on the top 5 models using Taylor diagram analysis. The seasonal and spatial characters of the MME were compared with the observations-based dataset, including aquamodis and sonar preference. Our findings showed that the MME successfully reproduced the spring phytoplankton blooms chlorophyll concentrations. Although the onset was delayed by about 1 month compared to observations, however, the full bloom observed in satellite data was not captured. For PCO2, the MME replicates the latitude gradient and high seasonal variability, particularly the low PCO2 in the mid-latitude band during summer. Despite this performance deteriorated in coastal water due to the model's low spatial resolutions. Overall, the MME efficiently captured the large-scale seasonal dynamic of chlorophyll and PCO2 in the Northwest Pacific. However, model improvements are needed to address bias in bloom timing and coastal regions. This finding enhances our understanding of oceanic carbon uptake process and contributes to refine future climate projects. Our next steps will involve improving model resolutions and incorporating more advanced biological process to better simulate ocean atmosphere CO2 exchanges. Thank you for your attention. I look forward to your questions and feedback. Thank you.
네, 감사합니다. 접속 종료해 주셔도 됩니다. 지금 접속해 계신 분,
감사합니다.
네, 지금 접속해 계신 분들 전부 접속 종료해 주셔도 됩니다. 이상으로 제3회 빅오션 인터내셔널 메타런스 종료하도록 하겠습니다.
예, 그동안 오늘 수고했고요. 그 다음에 다음 제4회 메타런스는 제대로 좀 할 수 있게 저희들이 더 완성도 있는 플랫폼을 개발하도록 하겠습니다. 지금부터 from now on we will scan the invitation poster is the first Khalifa University. From Khalifa University we will scan all America and then Australia, India is the we will do. Okay, thank you very much to participate in the third international big ocean meteorance. Thank you very much.